अज्ञानतिमिरान्धस्य ज्ञानाञ्जनशलाकया चक्षुरुन्मीलितं येन तस्मै श्रीगुरवे नमः. Which means salutations to the Guru, who with the collision of knowledge opened the eyes of one blinded by the darkness of ignorance. A very good morning to one and all present here. On this auspicious occasion of Guru Purnima, let us first offer our respects to all our Gurus. As a part of 10x AI Research Acceleration and Revolution Scope and Future Ahead Faculty Development Program, we are grateful to our teachers and parents who have guided us knowledge in the right way. On behalf of Amrita Institute of Engineering and Management Sciences, happy welcome to you all for the Day-2 Faculty Development Program. Today, we have first session by Dr. Raghavendra A.L. in a topic Statistical Analysis and Visualization using R Programming. Now, I request Professor Sidramana S.C. to come forward to introduce today's speaker to the gathering.
Good morning, everyone. It is my privilege to introduce our distinguished speaker, Dr. Raghavendra A.N., Associate Professor and Program Coordinator for BBA Vision Science Program at School of Business and Management, Christ, Deemed University, Bangalore. Dr. Raghavendra has over 2 decades of teaching and research experience in the field of human resource management. He holds an MBA from Bangalore University, has qualified UGC NET and earned his PhD in International Human Resource Management from Visvesvaraya Technology University, Belagavi. He has an impressive academic record with 30 research papers, several journal articles, and book chapters, and has participated in over 45 national and international conferences. His ongoing ICSSR minor research project focuses on the impact of mindfulness in reducing student anxiety in higher education. Dr. Raghavendra is proficient in statistical and analytical tools such as R, SPSS, SAS, AMOS, Tableau, and Excel, and has conducted numerous workshops and faculty development programs. He also serves on the Board of Examinations for 2 universities in Karnataka. Today, he will deliver an insightful session on AI-assisted statistical analysis and visualization using R programming. We are confident that his expertise will provide us with valuable knowledge and practical insights. Please join me in extending a warm welcome to Dr. Raghavendra A.N. Thank you, sir, for joining us. Over to Dr. Raghavendra.
Very good morning to all of you. Am I audible? So, wish you all a happy Guru Purnima once again. As it is rightly mentioned that Guru Brahma, Guru Vishnu, Guru Devo, Maheshwara, Guru Sakshat, Parabrahma, Tasmai Shri Guruve Namaha. So, it is the teacher who gets lot of respect in the society apart from the parents. So we are in such a global profession, most of us here, that we can harm the citizens of our country as well as maybe the world also now because there are no boundaries. So today, I'll be just giving a glimpse of how AI can be used in order to do the statistical analysis with the help of our program. As you all know, now it is an AI era. It is there in almost all walks of life. In fact, we cannot survive without AI. We have come to that stage now. Even in fact, the children in the school, they are also given a lot of sessions on AI and how they can utilize. And sometimes we can also agree to this fact that these college-going students know better usage of AI than us. So they adapt to the situation very fast. So they can use AI to the greatest. And we all know that artificial intelligence, as the name itself suggests, again it is made by the human beings. There are people, the software engineers, who train these models day in and day out and make the life simple for many of us. So we also should agree that this artificial intelligence, though it is giving us so much help and though it is helping us in many ways, it is the human creativity which stands above us. Because the human being has created. Many people wonder that because of this AI we lose the jobs, we may not have the jobs. But actually AI has created a wonderful opportunity for us to get many more jobs. So now that you know that AI is found everywhere, we cannot believe also whatever AI gives is true. Because whenever something are discovered or some things are developed, the same human beings who go with the anti aspect of that, like how when we had computers in the beginning. So in order to have a very good business, they came up with virus. So that the company started making antivirus. Now we have the same thing which is going on in AI also. You must have seen that AI also gives wrong answers. We don't know whether that is right or not. Okay, so that is what I was telling you, that there is what is called as weak AI and strong AI. So weak AI is something like what we use these devices like Alexa, then this iPhone, Siri, wherein they will do some whatever the instructions we give, we call that as a weak AI. Whereas the chatbots and the LLMs which we are using, large language models like ChatGPT, Claude, Gemini, now so many are there. So these are all, we cannot call them as completely strong AI, but they are okay, moderate AI. But the strong AI has not come into picture wherein it can completely mimic human intelligence. That is, I think, almost near to impossible, completely replacing the human. That is what AI is going to help us, but it cannot replace that entire human being. So, with this, let me just give a brief introduction about what is that I am going to cover today. See, AI assisted statistical analysis and visualization using R. So R is a software, as you all know, it's an open source software. How R can be used in order to do the statistical analysis with the help of artificial intelligence. So we'll be basically covering today what is AI, how AI can be used in statistical analysis, what is this R programming, and how we are going to embed all these three: AI, statistical analysis, and R programming. So this seems to be not that much advanced topic, but it is very important for us to know that to take our research journey further. So agenda for today is we will have a little bit of foundations, then how to handle the data, then descriptive and inferential statistics, then we will also see some of the visualization and how we can use the AI in order to do our analysis and some hands-on exercises. Can you go to the next slide? So the learning outcomes of this session, what I am going to take will be to understand how AI can support the statistical analysis in R. So how AI can be used so that we can do a better analysis and import, clean and prepare data sets in R. Then we can see how to perform the descriptive and inferential statistical analysis, how we can do that, and how we can generate the meaningful graphs and visualizations using this R programming. And finally, we will see how to use this artificial intelligence to assist with the code generation, interpretation, and reporting. Now, go to the next slide. What is AI-assisted statistical analysis? So, all of you have the systems with you because we need to do the hands-on whenever I explain. So, if you can do it immediately, you will be able to understand the topic. Otherwise, if I give it as a lecture method, then it may not be that much effective. So, how many of you have the systems here? Can you please raise your hand? 3, 4, 5. So rest all. So then you would like to watch just what I am doing it, and you would like to practice it later. Hope this is recorded, this entire session. So if the recording is there, then fine, because you can take it and you can practice it afterwards. Okay. So now, as the name itself suggests, AI-assisted statistical analysis. That we all know sometime back how if many of you have done your PhD, how it was so difficult for us to first of all get the literature review done, go to some central library, sit there and get that one. And there were some fat statistical textbooks wherein we were used to go through the topics and then we used to apply that techniques, especially with SP Gupta textbooks. I think you might be aware of. So it was so difficult for us, and many a times we used to outsource it to someone who can do that in a better manner, and we used to write on our own. But now gone are the days wherein we do this by going from one place to another place or sitting for a longer time. In fact, you know how earlier the data was collected, it was collected through manual form in the paper, and we used to code that. And after coding that, then we used to apply the statistical analysis and we used to write the interpretation on our own. But now, all these things, whatever it is, we need not do anything. Directly, you give one prompt to your AI, and that will do the work for you. I was told that by someone who attended this FDP yesterday, that IISc person, he was talking about a scholar who submitted his PhD with ChatGPT assistance. And when he submitted, then when they questioned him, he told that idea is mine. ChatGPT, I gave the idea, but it gave all the analysis. What is wrong in that? So that means you can see everything you can do it using artificial intelligence. But at the same time, you should know how to get the things done with this artificial intelligence in a manner so that you have the scope to rewrite in the places where you have your own ideas. Now we have come to a stage that AI should be accepted. It is not that we cannot say that we don't want to accept AI. Even if you write on your own and if you put it for the checks, similarity check or plagiarism check, it will say that it is AI content. Because already you know that whoever is training this model, see how AI works, all of you know in the background how it is done. There are some software engineers who train the models and they train in such a way that this will try to mimic the human intelligence and it will try to give the, it will try to think and it will try to give the output. So now whatever we are trying to get we can get the support from AI, but we cannot replace everything or we cannot just like that get everything and submit it for an assignment or for a PhD thesis. So that is not acceptable. So that is where we need the help of artificial intelligence, but due credit should be given. That's what nowadays, I don't know, those who are in the teaching field, we should compulsorily use AI now. But what is the usage? We should mention that in the assignments or the assessments that is being given to the students first. You all know that we have a course plan. In the course plan, whenever we give the assessments, in the assessment itself, we should write that how much usage is permissible. There are certain subjects like operations research, statistics, which the student should write the examination, for which AI usage is nil. There are certain assignments wherein they can use the AI, but they have to rewrite on their own. But there are certain assignments wherein they have to do it completely with the help of AI. Like for example, they will ask them to develop an app for some kind of daily purpose. Then they will tell them, you can completely use the AI, but what I want is the app should work. Okay, so now that is where AI usage, how it is permitted in the institutions or now even the companies are also using AI. It's not that they do not want to use AI. So here we are using AI in order to do the statistical analysis. The AI here we will pay with the large language models like ChatGPT, Claude, Gemini, like so many are there. We have DeepSeek, we have Perplexity, so many are there now. Earlier only ChatGPT was there, but like that now you can see n number of models now. So here we will pair that with the LLMs, we will pair them with the R software. That means whatever the coding that we are going to do, earlier we used to memorize the syntax. Now there is no need for that. We give a prompt to ChatGPT or Claude or whatever it is. That will give you the code. Just copy the code and put it in R and R will analyze it for you. You may ask, can't this AI do the analysis also? Yes, it can do. But sometimes there will be some errors which are nothing but the limitations of this AI, so that if you run in the software, you will get double confirmation. Okay, so that is why we use both of them simultaneously. So here R remains the computational engine, whereas AI acts as a co-pilot and the researcher stays in control. That means you have to validate the logic. Sometimes there may not be logic in the output that is given by the AI. So what you have to do, you have to intervene, you have to now check what you have done, whether the data collected is fine, whether there is any kind of issue with that data. So you need to check that on your own. Otherwise, the AI will give as per the data that is supplied to it. Okay, so yes. So the AI plus R workflow. So this typical research workflow moves through 5 stages. So that it can assist, the AI can assist at every stage while R will execute and it is going to validate the analysis. First we will do data importing, then we do AI assisted cleaning, and we can do the analysis in R, and we can do the AI interpretation, and finally we can report and visualize what we have done. And here one caution is that the researcher remains the final decision maker. So you are the final decision maker at every stage. If you feel that whatever you are going to get the output or whatever the ChatGPT is going to give the answer for your question or the prompt, then you can moderate that according to your ideas. So you have to come up with the difference between directly generated content with the original ideas. So you have to pair with that. Okay. Now, the AI tools in this R ecosystem, we use Claude, ChatGPT now, and GitHub Copilot is also there. Then GPT Studio, Chat ER is there, and AI assisted documents. So in R, we can have adding. So adding the GPT Studio can be used in R so that you can go and give the command, can give the prompt in R itself. But anyway, I'm not going to cover that. We will use the LLM, that is the large language models separately, and R software separately, and then we simultaneously use it. Okay. So now the next slide. How to set up this R environment? I hope all of you have downloaded the software R. Okay. So I'll just show it now. Now I need the system, so I'll go down here. So this is the software. This is R Studio. See, you will be able to get this screen if you have installed R console first. So this has got two softwares. One is called as R console, the other one is called as R Studio. So those who are having the laptop, hope you are able to get this R Studio. That is R console. You have to install R Studio. R is the open source software. That means it's a free software which anybody can use it. So this is the screen which you get when you open R Studio. In other words, R Studio works with the background of R console. R console should be there. I'll just show you the icon how it looks. R console. This is the icon. Can you see this here? This is what is called as R console. I think somebody, when you showed it, you are able to see this, right? Just now you showed it. This is called as R console. In fact, this is the main software, R console, and R Studio works with the help of this. That means this should be there in the background. Even if you do not open it, you should have installed in the system. So once you install this in the system, then if you search for R Studio, see, I can close this. There is no issue with regard to this. You can close this. Now you can open R Studio. So this is called as R Studio software, wherein it has got 4 compartments. You can see. So the left-hand side compartment is the place where we write the syntax or the commands. We write there, and we can run the commands. Whereas the output is shown down here. You can see in the console here. You can see that that is the place where we get the output. And you have on the right-hand side, okay, top corner. Here we have the environment, history, connections, and tutorial. That means whatever you are storing, that will be shown there. And at the bottom, you can see there is what is called as files, plots, packages. So R works with the help of packages. In fact, I had said yesterday what are the different packages that you should install. So all that packages you can, again, it works with the help of these packages. If you don't have that package, it will show error. Okay, R will show as error. It comes in a bundle. So that entire, all the packages, if you have what is called as CRAN, CRAN, that is developed by, again, the R software. It is called as comprehensive R archive network. So it is there. If you go to the website, R website, it will show there what is the comprehensive R network. So from the CRAN, if you say install all the packages, it will install everything. Okay. So otherwise, for us, we need 4 main packages now. That is, one is tidyverse, The other one is DPLYR, ggplot2, and then we have GPT Studio. You can have these 4 packages as of now. So that packages should be installed. So how to know that whether the package is there in your studio or not? So if you go here and click on these packages, if you see here, if I click on these packages, can you see there are these many libraries? Okay. If I click, for example, I want DPLYR. So if I say DPL, it shows how many are there packages with this. See? Then if I say I want tidyverse, I told you to download this. Then I told you to download Cycons, PSY. So see, tidyverse is here. Tidyverse. Room is also there. Like this, all the packages you should have. And anytime you do not have a package, but if you have internet connectivity, you can install it. Like for example here, if you click on install, see this is the package repository which I told you just now, CRAN. Okay. In this, if you search, for example, I will say I want the package GPT Studio. So if I say GPT Studio, see, the moment I am typing, it shows, it comes in a drop down. So now GPT Studio is there. If I click that, it will install that package. In fact, I have already installed, but once again, I will show you how to install it. So click on this and say, you can install all the dependencies. So if you click on this, see it is going to install here. It will show you. That's what I told you. This is the output window. So it has installed now. Okay. Now how to see that whether that package is there or not? So if you click here in this place, see it is showing. If I click GPT, it shows that there is this package. Okay. Now where is this GPT Studio? It is there as an add in here. So you can see here. See, this is GPT Studio is here as an add-in, and as a package also it is there. Okay. Now see, whatever I told you just now, this is the same thing. Okay. So how to set up the R environment first? Install R from CRAN, then install R Studio, then install 4 packages once per machine. If you do once, that is enough. If suppose that there is different versions of this, updated versions will keep coming in that R archive network. Okay. Always they will upload. Since this is the open source software, there are many people who work behind the scene, wherein they keep uploading these new packages as well as they keep updating the existing one. So whenever you are using an older version, automatically it will ask you are using the tidyverse in the version 4.4.3. Would you like to update it to 4.5.6? Like that. So you can update them at that time. So here we can see we can install 4 packages once per machine. Then keep an AI assistant browser. So like this one more browser you open. Now I have another browser called as Comet, where I have put all these LLMs here. See, for example, what I have opened here is the perplexity, this one. Okay. Then I have AI. So I have so many here. ChatGPT, Perplexity, Google Gemini, DeepSeek. We have Kiwi, we have Qwen, and other tools. Claude was also there. So for example, ChatGPT. I'll keep this on. So since I've already logged in, it is showing it for me here. Then one more I can add here and I can open this. So I can, this is Perplexity, whatever is there as of now. Then one more I can open Gemini, Google Gemini. So now this you can see Google Gemini is also there. Then we can open Claude also. Claude. So this is the Claude which I have used. Already I used it, so that's what my previous usage it is showing here. Okay, so this much is enough as of now. ChatGPT, Perplexity, perplexity.ai. Then we have Google Gemini, we have Claude. Okay, these are called the AI tools, or we call them as large language models. So you can also keep this open simultaneously. Now, let us go back to this. Yeah. So, for example, if I copy and paste the same syntax, I've given all this syntax yesterday. You see here what happens now. See, I am copying this. Now I am going to R software. I am going to paste it here in this place. That is left hand side top corner is the place where we have the syntax. So I will paste this here. Now install packages. These are the packages. Once again, it will install them. Like for example, now how to run the command. There are two options to do this. One is select all this, and there is a button called as run here. Okay, there is an option here, run. If you click on this, see it will run. Can you see down? It is installing again. All the packages it is installing. Okay, you can see there. It is installing. Whenever the installation happens, or whenever the R software, the studio is busy, it shows here one red color signal. That is, it is the work. Okay, it is the stop button is there. That means it is still installing this. It's not ready for taking the next syntax. So therefore, you have to wait till this icon disappears. That red color icon. See, it is still happening here. Okay, so I have already installed, but if I install it again, what happens? It overwrites that. It will overwrite the existing packages with the new version. So the new version will be that will install. Okay, now next we will see that how we are going to import a data set, either a CSV data set or an Excel file. You know what is a CSV file, right? It's nothing but an Excel file, but in the format called as comma separated value. Okay. So CSV stands for comma separated value. Either you can open CSV file or you can open an Excel file. So for reading the Excel file, there should be a package called as the read Excel. Okay. If it is not there, you can install it. If it is there, then directly you can get that one. Okay. Now what we will do is we will first import one file and then we will store it as DF. So DF stands for data file. So we will import first a file. There is a file which I have sent yesterday that is called as survey data. This file I'll show you before I start with the analysis part of it. So what does this file contain or it consists of? So you can see that this survey data file, this is the work which we usually do in our day-to-day life as teachers. You can see there is a serial number, the name of the student is USN, gender, age, what is this educational background, city of origin, what is the score that he has got in a particular examination, how many hours he studied, what is the attendance he has got, and what is the teaching method he has undergone. Now this much is the data that is there. Now what we will do is we will use this as a file today for our data file and we will do the statistical analysis. So what is the statistical analysis that we are going to do now is we will first do the descriptive analysis. Okay. Then we will see the predictive analytics and after that we will do the prescriptive analytics. I think you all know the difference between descriptive, predictive and prescriptive. So descriptive means it describes the data as it is. Okay. Whereas predictive means it will help us to predict the future. Okay. Forecast. Whereas prescriptive means it gives us some kind of recommendations that what we can use so that we can make that particular business better. Okay. So now this is the file what we have. What kind of descriptive statistics first we are going to do is we are going to find out what is there is a variable. We call each of the column as variable, each of the row as record. Okay, or records and fields. So now there are how many variables? The first one is called as unique identification. First, second, and third we call them as unique identification. They are not actually the variables; they are unique. Okay, so in other words, this is also called as a nominal variable. Okay, which we are naming it just for naming purpose. We cannot do any analysis with that one. Whereas after that, after three variables, the fourth variable onwards, that is gender, age, educational background, city of origin, score, hours studied, attendance, and teaching method, all these are variables where you can do further analysis. Now, gender.
The second column, there may be the repetition of the same name.
It can be. Yeah.
But it cannot be treated as a key variable or uniqueness.
Yeah, the third one is university seat number is there. No, that's a unique identification. Everybody will have different unique number. That's what in schools and colleges, why they give register number or USN is that the student should be identified by that. Two students will have the same name. But how do you identify that they are different? It's through the number what we give. In fact, this is called as the primary key whenever we do some analysis. So that with that, if you put register number, all the details of that student will come. I mean, nowadays we have all these ERP software to check about student details, with their attendance, their marks, their fees payment, everything. So everything, if you just put the number, we can see everything there. So that's how they have made the job easy for us. So this is like, for example, I collected the data from one of my sections where I am teaching, and I have done this. First, I have collected the data. This is the raw data. Now, first we will describe this data. I am just showing it for score here. That means, what is the mean score of the students? What is the median score? What is the mode score? Okay. That means descriptive statistics, you all know that it is nothing but measures of central tendency, measures of variation. We call them as well as measures of skewness and measures of curvature. These are the ones which we call them as the descriptive statistics. So, we will describe this now first. Just I am showing a sample. I am not doing completely. I am just showing a sample so that you can take it further and you can do the advanced version of it on your own. Because once AI assistance is given to us, we can do anything.
Is there any limitation for fields? How many fields it can do?
It can have a number of fields. It is not compulsory.
Even the records also.
Records also. How many are there? Like in the Excel can accommodate that many things we can. But only thing is that when you do analysis, sometimes there will be delay because it has got many records.
Because in real life situation, when we go for simulation of aircraft, to predict or to forecast the flying at certain altitude and all, before we send it flying, we need to test in a simulation mode, where there will be n number of variables. Is there any restriction of handling?
Definitely, we can have n number of variables, and there is an option in the software which we call it as bootstrapping. So bootstrapping means you can go on multiplying the data what you have collected n number of times. Like for example, I have collected a sample of 100 responses. I want the same responses to be duplicated to 1 lakh. I can do that. If I leave in the software, that will I need not have the data for because more or less the data is going to be the same. Okay, so like that, we have the option, but it cannot be infinite. There will be definitely finite. Okay, and if that is not possible with that many variables, that it should show a signal. Like I can do analysis only for these many variables, but the rest of it you should do it by first taking that, then club that and do the other variables.
Because in what we used to teach as supply chain management, supply chain network. So there are thousands of suppliers, n number of manufacturers, lakhs together dealers, warehouses and all. We build a network, a lot of n number of companies.
Correct.
We cannot imagine.
Whatever we are having, whatever the number of rows and columns the Excel can accommodate, that many fields and records we can. But otherwise, then if Excel is the limitation, then we have so many other formats of mentioning the data. So there is PDF file, text file, even so many other formats are there. We can directly, that's what we call as data warehousing and data mining, which, okay. So now, so yeah, Excel file I will explain you. Now let us see how we do the analysis of this. I will close this file. Now the same file we need to import into R. So how do we import? There are two options. It's very simple. One is there is what is called as import data set here. Click on this import data set. See, this is what I was telling you. There are so many ways which you can import the data. Either you can take it from text, or you can take it from text or read text, from Excel, from SPSS, SAIS, Stata. Again, these are all software, other software. Now I want to take it from Excel. Then it will ask the path where it is. So I will browse. I have saved it in one of the folders here. That folder name, I will open the folder. In that folder, which is the file, this is survey data. I open. See, the moment I click on this, you can see the data here. Preview. This is called as preview. Okay, and this is the syntax which it has written automatically. Can you see this? Either we can write the syntax there and run it, or you can click on import data set, and that if you say import, so click on that import. Click on that import. Import is there now. See, now it has imported. You can see where is that imported file? Yeah. Can you see? See there? Now that imported data file automatically pops up there. Earlier this visualization was not there in the previous versions of the R Studio what I was using. Now see, this has been included. So that means this software I updated for the latest version, what was there by yesterday. Then it is giving me this quick visualization also. I can see a serial number and all. So like this, you can see serial number, name is unique, then USN, you can see this here. This is visualization. This is a summary which it is showing here. If I click on this again, that will disappear. Now this is the data with file which it is opened like this survey data. Can you see this? Another R script is open automatically. This is called as R script. Untitled is there, no? This is called as R script. Okay. This is R script which we are doing. So this is the survey data file. This is the data file which is open. Let it be open there. Now what we will do is, instead of giving such a big name every time, let us make it short. Let us call it DF. DF stands for data file. Now how to store this as the file is? The syntax I have given again yesterday. You can see this. This is the syntax which is given. That is DF less than symbol, hyphen symbol. Less than hyphen symbol indicates concatenation. That's the technical term which we use. Concatenate means store. Survey data file is stored now in a new variable name called as DF. That means wherever we put DF, you can see the file automatically. The file pops up. Okay. That's one. Okay, now see this, the syntax is there already here. So I will copy this syntax and I will paste it in R here. See, DF, this is DF survey data what I have made. I will run, sometimes we have to run line by line. Sometimes the entire syntax once for all we can run. If you run once for all, that means it's a function actually. If you read one by one, that's the syntax each line which you should run separately so that you get the output. Now here DF less than hyphen symbol means you are doing concatenation. Concatenation means storing the variable, storing the file. So now I will run this. How to run? There are two different ways. One, you can click on this run, or you can also say control enter button. If I say control enter, can you see this? It is now it has become DFPL. What you are doing, that commands, the output comes here, whereas what is happening in the background, it will, the storing of the variables or the data, it happens here. Can you see this? These two are one and the same. It was survey data, but now it is data file. Because let us use it as data file. It is easy for us. Now, whenever you give in R this as symbol like that, as symbol there, that means it's an explanation. It's not the command or it's not the syntax. So that's why you can see it is in some other color, green color. Now, when you have this, so a quick structural check we will do for this data file. One by one we will run. First, str means structure of this data file. Okay. So if I click this, can you see this down? Can you see here? What is the structure? It is showing this many structure. STRDF if you do. There are 72 rows and 11 columns. That's the meaning of 72 into 11 here. So what are all there in that? The first one is serial number column. That is a numeric. The second one is name. You can see your characteristic there down. Can you see? Okay. So this is what STRDF means. The structure of your data file. It is showing there down here. Can you see this? USN, gender. What is gender? It's a character. Okay. What is the other one is numeric. For example, age, score, all these things are numeric variables. So now you can see here. Next, what is DIM? DIM. DIM means dimension. If you run this, it will give us how many dimensions means how many rows and columns. 72 rows, 11 columns. Then next one, you can run head DF. If you run this, you can see head DF comma 5 means head means it will give the first 5 rows. Tail means it will give the last 5 rows. Okay, sorry. Head DF comma 5 means it will give only 5 rows. But if you give by default just add DF means it will give 6 rows. So 6 rows will be there. You can see now there is a difference here. Same way, if you give tail DF, it will give 6 rows in the end from the last. See there, 73, 72, 71 like this. Now, this is importing the data. First, whenever we have the data set, we will first import the data. Once we import it, then we clean the data. That's what we also call it as data preparation. So, what do you mean by data preparation or data cleaning? Any idea? Yes. Anomalies in the data, discrepancies will be there. What do you mean by anomalies or discrepancies in the data? Yes?
Any null values are duplicate values.
Yeah. Sometimes there will be missing values. In fact, I will show you in the data, it is there like that. Some places it is missing. When we collect the data from the respondents, they would not have filled it. Or when we collect the data, they would have filled something wherein it's some kind of symbol which doesn't have meaning. Instead of writing age as 35, they have written it as A1. What does A1 means? We don't know. So that is these kind of things, we call them as some kind of discrepancies in the data. So these things, before subjecting it to analysis, we should clean the data. We should first prepare the data. Then you subject it to data analysis. Otherwise, what happens if you don't clean the data, these missing values, it will take it and it will do the analysis where that missing values, let us suppose if very few are there, that is fine. But if many missing values are there, then it will not represent the entire distribution. It is going to be only some kind of approximate analysis which it is going to give it to us. So therefore, we have to clean the data. That is what is the next one. Okay. So Now, if you see here, cleaning and preparing the data with DPLY. So this is the package. So what we will do is we will copy the same syntax and we will paste it here. We will paste it here. But before that, let me show you the data, survey data, what we have taken. Here, survey data. When you see, can you see some numbers are missing here? See here, NA. Can you see? It is showing NA here somewhere. Yeah. NA means not available. Like this. Then you can also see some places there is NA. NA means not available. It is they have not filled it. Here, NA. In the main file, if you see, you can easily make out what are those missing values. You can see it. Like I will open it. You can check this here. See this here itself. You can see one value is missing in our study, number of hours studied. So many missing values are there here. See, one age is also missing here. Okay. See, like this. These are the missing values. Now, what we have to do with these missing values? So, there are two. First, let us try. Let me show you this. See, whenever you are cleaning this, first you have to all the variables, like for example here if you see in R environment, you can see here city of origin, C is capital, O is capital. Can you see this? Then if we go this side, you can see this. Here gender, USN all capital letters, G capital letter, A capital letter. Now what we will do is we will make all small letters. That's the first thing which we will do. All the main variable names. Okay. So for that the syntax is written. Now I will run that. So this is the command which syntax I have already written. Library DPLYR, it should load this. Okay, see it shows here. It is loading here. Whereas it is giving us a warning message. What is the warning message? The warning message is it is built under version 4.4.3. But now there is a better version. So the better version is 4.5 something you have. Okay. So now this if we say, now what will happen? The DF, that is data file, we will make it as another data file wherein we are cleaning that and we are reloading it or we are restoring it. Okay. So now instead of DF, we will make it as DF under clean. That means that is the cleaned data file. Whereas DF is the original data file. So that you can make the difference between the two. Okay. So now what we will do is we will store it as a different file name, that is DF clean. So what it has to do, see this is the syntax which we have got from the AI assistant. The same thing we will paste it here. So I will run this. So when I run this, what happens you see? Can you see here? It is showing blue color here. That means it has already run the command. Now how to check that one, whatever you have run that command, see this is the data file, what it is there, right? So you go and you check with that view data file, view DF. So if you say view, when you type view, you get that. View DF underscore clean. So if you say DF underscore clean, if you view that, DF clean we have not yet stored it. Sorry, we must store it. Just doing it again. So now I will run. Yeah. So I left one bracket here. That's what I could not get. Let's say now DF clean is here. You can see this. Even if small error is there, it will not give us the output. Now DF clean, if you want to check how this file looks like, you say view. Then the moment you click some syntax, no, it will show it here. That is there. That already view is there. So view what you want to view. We want to view DF. So DF clean, DF underscore clean. See, that also will come here. Okay. Now, if you see, if you run this, see here, DF clean. Can you see this? Earlier, I will close this, or I will show you the difference between these two. This DF clean, you can see all it has become small letters in the heading. All heading has become small letters. Can you see here? Age, gender, educational. But you see in the original survey data file, they are the first letters are capital letters. Okay, that's the difference. First it has cleaned it. Okay. Now, what we will do is the next thing is how to handle the missing values. So that's the next syntax which you should know. That is, for example, how to know where or how many missing values are there and how to handle these missing values. There are two different ways of handling the missing values. One is either you delete that particular record completely, or you can impute that. Imputation means, like for example, if it is age, what happens? All the ages, whatever is there, except that missing value, it will take the mean or median or mode, and it will substitute in that place. Okay, wherever it is missing. See, that is what there are two options. One is remove incomplete row. The other one is clean that using imputation. Okay, so we can impute that. I will show you the first option. Out of 72, now let us remove the missing values and see how many finally the rows or columns will be available for us for statistical analysis. The same procedure you can repeat with imputation also. Okay. Now what we do is we will copy this. So the syntax for missing value. So let the file be in the background. Now I am giving the other syntax. So how to count the missing values? You run this command. So if you run this command, now can you see this down? See here, in which variable the values are missing. For example, in the first variable, serial number, name, USN, gender, age, educational background, city of origin, there are no missing values. Whereas you can see the missing values in the score, 6 values are missing, R study, 2 values are missing. Whereas rest all, there are no missing values. Okay, first is to find out how many missing values are there. So that means out of 72, 6 students' score is missing. First method of cleaning or fixing this is deleted. So that means out of 72, if you delete 6 rows, what will happen? We will have only 66 rows for further analysis. Okay. So now you see here, next command if I run. So now what happens? It will clean that one. It will remove those values. Now you view DF. Now you see in DF clean, can you see there now? Can you see there now showing 1 of 9 of 66? It is showing only 66 now. That means 6 rows it has deleted. Because 6 rows, we see that 6 scores are not there. So therefore it has deleted. Now you can see this. That means, see this DF clean, the file which was in the background, we didn't do anything. Automatically it has deleted. Okay. Because we gave that particular syntax for that, the command for that. Now, the next thing is, This is where we call it as the descriptive statistics. Let us do some description of this score. Score is one variable. Now we would like to check what is the minimum score, what is the maximum score. So in the day-to-day life of the teachers, we will be checking this thing. Whatever the subjects we teach, whenever we do the assessment, we want to see that who has scored least, who has scored highest, and what is the majority of them have scored. So when we want to check that one, we use the descriptive statistics. So now we will find the summary. So how to find the summary of the score? So click on this and say summary score. Now when you give summary score, see what is that it is giving for us. You can check it. Can you say this? You can see minimum score is 54, whereas maximum score is 93. That means too much variation is found in the score. Here itself we can make out, right? Minimum and maximum. The difference between minimum and maximum is called as the range, right? So the range is very high. One getting 54, the other getting 93. Almost like 40 difference is there between them. And you can see what is the first quartile, 62. What is third quartile, 81. Whereas mean is 71.39 and median is 69.5. Okay. So you can see this is the summary. Now, whatever the summary you have got, you try to interpret that. How interpretation can be done is using the AI. So what is that interpretation? I will show you using AI. How to write the summary. If you want to explain this to someone, how are you going to explain it with a description? Can you see this here? It is shown here graphically also, and we got a score. Now, AI assisted interpretation prompt. Now, how can we interpret this? There is a prompt. We will copy the same thing. For example, I will copy this and I will copy the output also and give it so that how it gives the output in the AI. Let us see that one. So first I will copy this. Modify open so that it is easy for me. So the score is here. What is the summary score? In R, we have got the summary score. So we can copy this. So I am copying it and first pasting it. So this whole thing is the prompt. Now I copy this. Control C. I will go to this ChatGPT. Okay, so ChatGPT here. I'm using ChatGPT now. So in ChatGPT, okay, now I am going to paste this here. Can you see this? In ChatGPT, I have pasted here. Given this summary score output, write 2 sentences interpreting central tendency and spread for a non-technical reason. Now, if you want to explain it to someone, you know that. But when see, this is what you have the output, but instead of you writing it, you take the help of so that it will write it for you without grammatical errors. So now, how to run this? You know, all of you know how to use ChatGPT. So therefore, you click on this button. So see this, what it is giving now, how it gives the output. So ChatGPT will think, it will check what we have given, and it is going to give us the output. So what is the output? I think the internet connectivity is slow. It has come. The average score was 71.39, while the middle or the median score was 69.5, indicating that most participants scored around 70 out of 100. That's the meaning. Okay, average means majority of them have scored around 70. and the scores range from 54 to 93. This is the range I have told you, with the middle 50% of scores falling between 62 to 81. What is 62? What is 81? This is our first quartile, and 81 is the third quartile. You know quartiles, right? They are called as partition values. Okay, quartiles means which divide a distribution into 4 equal parts. So first quartile divides the distribution in such a way that 1/4 will be below, 3/4 will be above. Third quartile, 3/4 will be below and 1/4 will be above. And median is also called as second quartile, which divides the distribution into 2 equal parts. Okay, so that way showing a moderate spread in performance among the participants. So how is the spread? You can see that it is given here. This is the summary. In summary, it gives mean, median, and it is also giving us first quartile, third quartile, minimum and maximum. Whereas if we want standard deviation, skewness, kurtosis, all that, we can use what is called as a package, which I have discussed in the beginning. Use that package and then ask for the summary. That time you will get the extra output. Okay?
Sir, you have another question. Instead of using our software, what you did all the importing of the data, cleaning of the data, if I directly copy the data set into the chat GPT and ask to clean the data and do the analysis, do you mean to say that it won't give any the mean, median, and all?
I told in the beginning itself. Now it is not just the score. You do everything. If I give the Excel file to the chat GPT and ask it to write the descriptive statistics for everything, it will write immediately. Now what I told in the beginning itself, the caution is that I am going to show in such a way that how the chat GPT or the AI, you can use it only in the place where it is required, not everywhere. Ideas should be yours, but ChatGPT should help only to analyze. That is where we can reduce our plagiarism. So otherwise what happens? Yes, definitely it will give. Everything it will give. AI will do everything for you. But why I am showing like this is, sometimes whatever the R as a software gives the output may not be the same what ChatGPT gives, because ChatGPT can commit errors.
Yes.
So while writing the code, syntax, so all these things, it may not fix it properly.
Have you tested the result which is given by ChatGPT?
Let us just say,
Is there any variation?
of course, there will be variation sometimes, may not be every time.
Yeah.
It may not be every time. The variation need not be every time, but there will be sometimes. But that sometimes only is very important for us. When we commit error there, things might go wrong drastically. So that is where we are doing development. And otherwise, all this whatever I am explaining in 1.5 hour, I can do it in 2 minutes. It may not be even 2 minutes. It will give everything. That's what I gave the caution at the beginning itself, that AI can do everything, but sometimes it makes mistake. And I also told one thing in the beginning regarding the computer, virus, antivirus. Now ChatGPT or all this AI is going through that phase. What they are doing is they are not training the models properly. It is giving wrong answers for us. See, for us, okay, in this context or maybe in a smaller context, it is fine. What if in business scenario they use it and they go wrong and they present it to their client, their business is lost. So that is where the companies also use this, but they do a judicious utilization of this, not just like everywhere use ChatGPT. What we do nowadays, no? If you ask us to do something, we will immediately put in ChatGPT to write a message to your friend also, so that there is no grammatical. To that extent, we are depending upon that. And the other person can easily make out that it is not your message, it is the ChatGPT message. Even now to write some mails, messages, emails, you just give the prompt. I want to write an email that tomorrow I am not attending college because of so and so reason. It will give you a beautiful letter. You paste that one and send it as an email to you. To some extent it is fine, but not always. Your originality is lost. Okay, so that is where I am showing you. Otherwise, this entire exercise of showing you the analysis, you can do it within 5 minutes if you want. Okay, but why I am showing toggling between this and that is that, like how to confirm, how the software is there for you to give the actual output. how that you can put it in the AI and get the interpretation done for you. Even interpretation, you should not write as it is what ChatGPT has given. You should tweak it. You should use your terms also in that one so that you can reduce the plagiarism.
So we should not use any shortcut methods. We
Yes.
proper things and implement.
That's what the problem. Now there is even that ethical usage of AI, that concept everywhere people are talking. You do everything through AI and you tell that you have done that. That is where the problem arises. And that's where they are telling that you should also give the credit to use it. And I also mentioned about this in the very beginning that what is the extent of AI usage you can do it in particular assignments. Even in the company also they will give them a list. For this you can use AI, but for this you are not supposed to use AI at all because that is where is our niche area where we need to give our interest. So like,
One more question, sir. Is data required, data cleaning is required anyway, sir, and to what extent data cleaning is required, sir?
the data cleaning is required if you see any missing values or any kind of, I told you, discrepancies in the data. First of all, to check whether there is such type of discrepancy, that's what we gave that command. To check whether it is there, that column, NEI, that one. If you see that there is no missing value, there is no need to clean, directly you can.
Missing value sometimes the value which is not expected also. If the,
Outliers will be
if the age is less than 100 years, it gives 500 years. No one can give human being 500 years. Such anomalies can be automatically deleted by the agent.
So that you can detect that. See, sometimes maybe if I give 500 also, it will take it for analysis. But your analysis, what it is showing, that is going to be, it is influenced by too much of outline and it is not going to be the actual analysis. So, yeah.
Does it depends on the objective of what we are doing?
Yes, of course. Objective is very important. Many a times, we do all these things with a reason in mind. See, now, what I am doing now is, there is a purpose to show you like this. Otherwise, as sir told, immediately I upload the data file and immediately show the analysis.
If the data in real life situations, data are latched together. If the data is entered by a human being, there are definite chances of making mistake.
That is what they call it as big data analysis.
If you collect the data in real time through software and other things, analysis will be less.
Yeah. Now, as I told you, if you load this PSYCH, the site package, you see how the difference happens here. You run the command describe df clean. Now, if you say describe, can you see here down? In addition to whatever we had, we also have skewness and curtailness. Like for example, you can see 0.36. Curtailness is minus 1.15 and standard error is 1.36. There is standard deviation also. You can see, okay, variables. How many variables? VARS means variables. One variable only we have taken, that is 4. So we have got these many details. Okay, so this is how we do the data cleaning and we are going to do the descriptive statistics. I'll go a bit fast now because now you have got the hang of it so that we can. The next thing is visualization. Visualization works in R programming with the help of a package called a ggplot. GG stands for grammar of. So GG means grammar of graphics. So ggplot2 is the latest version of that. So we use the ggplot so that we can have a lot of visualization. In fact, R has got good visualization. You would have heard about data visualization. Nowadays in companies, if you want to explain your managers, you cannot show them tables. They don't have that much time. So they need to see everything in the form of visualization. When they want to see everything in the form of visualization, which is the best software nowadays is Power BI. I think you might have heard about Power BI. Earlier Tableau was there, but now we have Power BI. Power BI is a wonderful software where you can import the Excel file and you can do lot of graphics in that one and you can explain. Especially our result analysis, we are doing using Power BI and we can check so many things in that one. Whatever the different kinds of queries we have, we can check with that. Okay, so Power BI is the best software for data visualization, but you can do data visualization even in our software also. Now, how are we going to do that? So this data visualization means it is shown in the picture form or a diagrammatic form. You all know that a picture is more worth than 1,000 words. So you explain about something in 1,000 words, but the same thing if you show in a picture, it catches your attention fast. Okay, so that way, the next thing is how we can draw the graph of this, whatever just now we have discussed. Okay, so we will see that histogram for this score, how the students are scoring. So copy this syntax and we can paste it here and we can run this. So first we have to run the ggplot2. It will load that package. Then next this entire command ggplot from here you run this. Okay. Can you see where did the output come? It has come in the bottom right part. See here you can see visualizations. In our visualizations will be here. Okay. So this is the visualization of the score. Now what we did previous one was in terms of numbers. The same thing if you put it in graph form, you can see this. Between 50 to 60, how many are there? Between 60 to 70, how many are there? How many have scored more? All these things we can easily get to know in this. This is called as a histogram actually. You can go with histogram, you can go with even the other line graphs, bar graphs. There are so many pie charts, so many types of visualizations are there. Then, now let us see the scatter plot between R studied and the score. Now we want to check okay, now you see this is a scatter plot command or the syntax what I am giving. Can you see this here? Now why I am showing this scatter plot here is to understand whether there is any correlation between two variables, that is score and hours study. So number of hours a student is going to study and what the score is going to get if you check that one, whether there is any relationship. So now next concept what we are going to discuss is correlation and regression. Now what is correlation? It is a statistical tool which will help us to know the relationship between two or more variables. So if one increases, the other also increases, then we say that there is a positive correlation between the variables. Like for example, number of hours studied and the exam marks. Okay, the more the number of hours the student studied, the more will be their marks in the examination. Right? If you take like for example, rainfall and yield of a crop. More the rainfall, more will be the yield of a crop. But if the rainfall crosses beyond certain state, then less will be the yield of the crop. That is also positive. Right? Okay. So like this, what is correlation? So to understand that concept, we have drawn scatter diagram. Scatter diagram is the method of studying correlation. Now when you see this diagrammatic representation, if you can see how the values are scattered, they are scattered in the upward trend, right? So you can see that there is almost high degree correlation between the variables. What are the two variables? The hours studied and the score. So there is correlation. How much is the correlation? What is the strength of correlation? That is what we find it using Karl Pearson coefficient of correlation. You all know about this, right? So correlation can be studied using scatter diagram method, Karl Pearson coefficient method, rank method. Okay. So now we will see how you will get Pearson coefficient. This is what I explained you. So quickly, what is correlation? I will explain. Now, correlation does not imply causation. You know about this. So that is the disadvantage of correlation. What do you mean by correlation does not imply causation? If I take the marks of Amrita Institute students and if I take the marks of, let us suppose, RV College students in some subject, and if I take the correlation between these two, let us suppose that I am going to get some 0.8 something. In fact, correlation is measured using what is called as correlation coefficient. It is a single value which is going to tell us the amount of relationship between the two variables. It will always vary between +1 and -1. +1 means perfect positive correlation, -1 means perfect negative correlation. That means when one value increases, the other value increases with the same way uniformity. That is called as perfect positive. Perfect or negative means when one increases, the other decreases with the same difference. Okay. Whereas in between that, if you get 0, that means no correlation. If you get plus 0 point something, that means it is towards the upward trend. Whereas if you get minus, then it is towards the negative trend. So negative trend means when one increases, the other decreases. That is what it is mentioned there. Okay. Now, when I take this example, Amrita engineering students and the RV engineering students score, if you take, you will get 0.8. But this is just a relationship, but it does not talk about causation. What is the meaning of causation? That means just because Amrita students are scoring more marks, even RBI is also scoring more marks, it doesn't make sense. Okay, that is one of the disadvantages of correlation. It is also called as, such type of correlation is also called as spurious correlation or nonsense correlation. So therefore, this is overcome by what is called as regression analysis. So in regression analysis, there is causation also along with correlation. Now, if you are trying to find out whether there is relationship between scores of Amrita students and their placement, there is a meaning. I cannot compare with scores of Amrita students and the placements of RV College. It shows negative. For example, I am just giving you an example. RV placements are 100%. Let us suppose Amrita placements is 60%. Now, if you check that one, it will show negative, which is not true. Because their scores is different, whereas your scores are different. Accordingly, your placement will be different. So, therefore, regression will let us know what is the causation. Whereas correlation, it will not show us causation, but it will just show us the relationship which may be true, which may not be true. But when you want to check causation, you have to definitely see what is correlation. Okay, so you should see whether both the variables are related. If they are related, then only you go with causation. If they are not related, it shows there itself that no relationship. Why you have to check the cause? Why you have to check the impact? Okay, so now Pearson's R assumes a linear relationship and roughly normal data. Always visualize the scatter plot before trusting the coefficient. Now let us run the Pearson R, that is find the correlation. Now, how much is the correlation? The same thing, whether you can relate it with your scatter plot. See, in scatter plot, we could see that linear, that line, in between one line was there, which was showing as the upper trend. Okay, so how much, what is the degree of relationship? We will see that now. So now, first we will check with correlation. How much is the relationship? This much if I run. Can you see there down? Okay, you will see here. What is the value? 0.7932. That means almost there is 79% relationship. That is very good, pretty good. That there is almost 80% relationship between these two variables. That is, the meaning is 80% of the times, whenever you study more, you will get more marks. That's the meaning, right? Okay, so now this is the correlation, and you can see the scatter plot here itself. Both are matching. That means you can see this scatter plot. This is high degree correlation. High degree correlation means anything which is above 0.5 is high degree. So the value which we got is 0.79, which is 0.8, which is high degree correlation is found between these two variables. So scatter plot will let us know. It is a kind of method wherein you can verify your findings. Now, this I think you can see here. Can you see this? Now R is 0.79, a strong positive linear relationship, and it is statistically significant. 95% confidence intervals also you can see that. Now explain this core dot test output into plain language sentences. This is the AI. So we copy this, put it in a Word file, and we put the output also in the Word file. Go to this, you take this Pearson's product moment correlation, copy this and paste it here in the Word file, so that together we can paste it in the chat GPT. Okay, so I will copy this, I will paste it in the chat GPT here. Or I will use Claude now. We can use any one of these, Claude, Gemini, or ChatGPT, or Perplexity, whatever it is. I'll put it in ChatGPT. Okay. I'll paste it and I'll. Now you see what is the output that you are going to get. See, the Pearson correlation analysis showed a strong positive relationship between R studied and score, which is 0.793, indicating that students who studied more hours tended to achieve higher scores. The relationship was statistically significant, and these are the intervals and suggest that true correlation in the population is also likely to be strong and positive. So it will give us the interpretation of that. Now let us go to regression. Now in regression, as I told you, we are trying to find the impact, the influence. Now this is just the relationship, but what is the amount of influence? So here, whenever you talk about impact, you should have two variables. One is called as dependent variable, the other one is independent variable. Whereas in correlation, you may not segregate them as dependent, independent. Whereas in regression, you should segregate them as dependent and independent. Now, as per this, if you take number of hours studied and the score, which is dependent, which is independent. In general, if you think, score is dependent and number of hours studied is independent. Okay, the score, what you get, it depends on how many hours you study. So therefore, number of hours can vary. According to the number of hours which it varies, your score will be there in your examination. So therefore, score is dependent, whereas hours studied is independent. Like that, we have so many other variables. Attendance is also there. So you can take attendance also. Whether attendance and the number of hours studied, whether both these variables have an impact on your marks, that is the score. Okay, that is where we will check with the regression now. That is called a multiple linear regression. Whenever we use more than two variables, then it becomes multiple. Okay, so linear regression means two variables. Multiple linear regression means more than two variables. Okay, so now we will see how to use the three variables and get the regression output. So I am using here the score with the hours of attendance. Score we are going to check score is the dependent variable, R study and attendance are the independent variables. These two are the independent variables. Now I have run the command ln. Now we get the model summary. So what is the model summary? Can you see this? I think you know how to interpret the regression, right? So regression, if you can see there you have multiple R squared value, which is 0.63. You will have your correlation value also, correlation coefficient will also be there, and you can always write this in the form of an equation. That is what we call it as regression equation. So how do you write the regression equation? That is what here I will show it now. So regression equation is given by y is equal to beta naught plus beta 1 x into e, or it is also called as epsilon. So beta naught, y is the outcome variable or dependent variable, which is exam score here. X is the predictor variable, which is number of hours studied as well as the attendance. Then beta naught is intercept, whereas beta 1 is the slope, and epsilon is called as the error. Okay. So now you are going to get the output. See, next is the output window. So this is the command what we have given. This is how we got it here. Correct? Now this, if I put it in ChatGPT, I am getting the interpretation like this. R square is 0.633. Can you see it here? It is there here. R square is 0.633. Multiple R square. Now what does that R squared, what does it signify? That means there is a 63% variance or variation. 63% of variation in the dependent variable is due to the independent variables. That means 63% of the times your dependent variable is due to the independent variables. So now if you can check whether both of them are the significant predictors. One is the R studied, yes, that's a significant predictor because it has got plus 3.25 and the p value less than 0.001. Where you can see attendance is minus 0.055 and the significance value is 0.41. So this shows that attendance is not a significant predictor, but the R studied is a significant predictor as per the data which I have. It may not be true also. Whatever I am explaining here, that need not be true all the time. This is the data which I have collected. That means for that cohort of students, attendance is not a problem. If they study on their own, they will get good marks, whether they attend the classes or not. That's what happens. No? Sometimes it's not that nowadays attendance is compulsory that the students will get good marks. Even some of the students who do not attend, if they come and write exam, they will get more marks. So that means our study is more important than whether they attend the classes or not. Even that way also we can interpret here. Okay. So now I'll quickly show this slide only. Now that I have shown you, because due to the paucity of time, I will not do it in R software now. I will just quickly explain here. Can I ask you? Okay. See here, this is what? Yeah, assisted interpretation of the results. This is the summary. Now it has given here. What is that? It has given very clearly how much increase will happen. See, there will be an average increase of 3.25 points in the predicted score after controlling for attendance. That means don't worry about attendance. Every R study, you can see that there is an increase of 3.25 score in your examination. So that means there is how much percentage variation? 63.3% variation in your dependent variable, which is due to the independent variable. Go to the next slide. Yeah. Now hypothesis testing. So that was predictive analytics what we did. Now the last one is prescriptive analytics. So prescriptive analytics is done through hypothesis testing. So what is the hypothesis testing? You are going to validate your assumptions. Okay. So that how we can do, we have so many types of tests. Here t-test and ANOVA we are considering. Now in t-test we will compare means between two groups. That is, score is there. We will check whether the score is the same for both boys and girls, or whether the score is dependent on the gender. So that is what we will do. And also we will compare in ANOVA, we will try to check whether the score is going to differ with respect to the method of teaching. Whether the teaching method used is going to have an influence on the score, or whether all the types of methods, irrespective of the methods, the score is going to be the same. So we will check that. So here, in hypothesis testing, we will have two types of hypothesis: null hypothesis and alternative hypothesis. So null hypothesis always assumes no difference, whereas alternative assumes there is a difference. Okay. So a small p-value, typically less than 0.05, that suggests that H0 is rejected. If the p-value is greater than 0.05, then the null value is accepted. Okay, so H0 is accepted. Now, statistical significance is not same as the practical importance. Okay, so go to the next slide. So this is what we give the syntax: test t dot test score with gender. That means we are checking whether score is dependent on gender, or the score is same for both boys and girls. If you see there, you are going to get p is equal to 0.005, which indicates that the score, it is 0.005 means it is significant. That means H0 is rejected, H1 is accepted. There is a significant difference between the boys and girls with respect to the score. That's what most of the times we find that girls score better sometimes. Okay, so there is a difference. Same way, if you check with ANOVA model, if you see with the teaching method, you can see P is 0.41, which is greater than 0.05. Greater than 0.05 means there is no significant difference. Whether you teach using PPT or case study or any other teaching method, you are not going to get the difference. Okay. So the next slide. So this is what is the entire presentation what I had today. In fact, I had to rush through the hypothesis testing. That takes actually a lot of time for me to explain. There are many tests, but I have just restricted only to t-test and ANOVA. So now the prompt engineering, as I mentioned, that you should give the right prompt so that you will get the right answer. Now there is a tool. Now you can use same ChatGPT to give a prompt also. How should I write a prompt for getting this kind of analysis? So that will do the analysis for me. Next slide. Okay, AI for report writing and interpretation. See, you have to paste the output, not the raw data. Why I am telling you, sir was also asking that time that what if I can get everything in one shot? See, many a times you should not give the sensitive data to ChatGPT or Cloud, whatever it is, because that will have in the background that it can be misused also later. That is what we should not put our personal information in it. That's why even in the organizations, they will first train with the dummy data, and then what it does, the code they will get and they will run in the software. Did you understand what I told? They will not run the exact data in the ChatGPT. If you run exact data in the ChatGPT, it will be there in the background and it can be misused also. So therefore, they will run with the dummy data. Then that code they will take, they will put in their Python, in wherever that is file is there, they will replace with the original file. Then they will get the output and they will interpret. See, that's why companies, I was telling you know why you cannot do it everything with ChatGPT. This is the problem. Because it can lead to misuse of that, and AI can be used for unethical means also. Okay. So now ask AI to suggest limitations and also use AI to draft methods section describing the analysis steps taken. Quickly next one. Okay, so this is what we have done in today's class. So then finally next. So this is the sample data set we have used. And next, so this is the ethical consideration. These are the do's and the don'ts which you are supposed to do it. And then finally, next one, sir. So ethical considerations. This is very, very important. You have to, that's what, data privacy. You should not share your data. Disclose on accountability. The researcher remains responsible for the accuracy, not the AI. AI will never come to your rescue. Okay. Also disclosure. That's what nowadays they will ask us to disclose how much AI you have used. And if they find it out that you have used 100% AI, then they might invalidate your findings. They will say that we cannot accept it. And also bias awareness. So that is AI suggestions can reflect biases also. So therefore, you should be very careful. Then the previous slide. So this is what the key takeaway is, which is nothing but about AI assistance in statistical analysis. What is the descriptive, what is predictive, what is prescriptive, and finally we have the ethics in AI usage. Okay. So that's all from my side. Any questions? Or any feedback? Hope the session was fine. Because this, which can be covered maybe in 4 or 5 hours, I try to cover in 1.5 hours. Actually, still lot of practical session. We should do it together, hands-on. If we don't do that one, it's just like another theory wherein you don't feel that it is very interesting. Yes.
The face is saying we have to install certain things. Practically the things to understand, but there are doubts also we need to take the proper questions.
Yeah. See, whatever doubts you have, because of paucity of time, I may not be able to address them now. I think so. We have a next session also. So you can send all the doubts to Nagananda sir. So let him forward it. I will reply to that through the mail. Okay. So I will send the replies. That's fine, sir. Okay. So thank you very much. So I would like to thank Nagananda sir and the entire team for giving me this wonderful opportunity to address this lively audience regarding the AI assistance using statistical analysis using R software. So thank you.
On behalf of Africa Institute of Engineering and Management Sciences and all the participants of the 10th RAR Faculty Development Program 2026, I take this opportunity to thank our speaker, Dr. Raghavendra Iyer, for taking a hands-on session in our FDP. Sir, your hands-on session on statistical analysis and visualization using our program was really excellent, sir, and you have highlighted the concepts of how AI can support statistical analysis in R, and by using AI and RAR, how we can get the results faster. We are very grateful to you, sir, for spending your valuable time with us. And now I request Dr. Anita N, Professor of Department of Electronics and Communication Engineering, to come forward and to present a small gift to Dr. Raghavendra A. sir as a token of love, respect, and gratitude. Please give him a big round of applause. Thank you, sir. Now we have a 5 minutes of break. After that, the next session will be started. Thank you, one and all. Shankar, Assistant Professor in the Department of Psychiatry at the National Institute of Mental Health and Neurosciences, Bengaluru. Dr. Gadigankar is a renowned psychiatrist specializing in addiction psychiatry and behavioral addictions. He completed his doctorate of medicine in addiction medicines from NIMHANS after pursuing his MD in psychiatry. His clinical and research expertise spans addiction psychiatry, neuropsychopharmacology, clinical psychiatry, and the management of substance use disorders, including narcotic and opiate addictions. He has authored numerous high-impact, peer-reviewed research publications and has made significant contribution to public health crisis management and the development of clinical guidelines. His work focuses on improving mental health care through evidence-based practices and innovative approaches. Today, he will deliver a session on AI in mental health, where he will discuss how artificial intelligence is transforming mental health care through early diagnosis, personalized treatment, risk prediction, and intelligent clinical support system. We are truly honored to have him with us today. On behalf of Amrita Institute of Engineering and Management Sciences, I extend a warm welcome to Dr. Deepak S. Gadigankar and invite him to address the gathering. Thank you, sir. The stage is all yours.
Hello. Good afternoon, everyone. I'm Dr. Deepak. I work as an assistant professor of psychiatry at NIMHANS of Bangalore. And at the outset, let me start by thanking the Amrita Institute of Engineering and Management Studies. Thank you so much for inviting me to address such a wonderful gathering here. I understand that there will be both online as well as offline presence. So thank you for inviting me. And today I'll be focusing in giving a little bit of an overview of what has transpired in terms of use of artificial intelligence in mental health. I will spend a few of my first minutes in describing as to what are the usual things that are happening, what are the current models that are being used in terms of use of AI in mental health. And later I focus majoritarily on the evidence base that has been gathered for early detection and treatment of the mental illnesses in psychiatry. So with that, I would begin. Let me start by engaging some of you here who are present in attendance here. I would like to know about, this is something that I would have done if the slides are presented also, but let me give you maybe a case vignette or 2 or 3 examples that we very commonly see in our clinical practice. Again, let me start with a disclaimer that these are hypothetical examples, and any resemblance to any person that you may or may not know is coincidental. So what I want to start with is a clinical vignette that you may see anywhere. It's a vignette, or it's an example of a 20-year-old boy who is currently studying in an engineering college, and he has exams coming in about 2 weeks. Now, just before the exams on one night, and he wakes up from his sleep at 2 a.m. and he can experience that he is very, very worried about the upcoming exam. He has symptoms of palpitation, his heart is racing very fast, he has become very sweaty, he is very worried and can't stop thinking. This is working. Yeah, so my outline would be I would initiate with two case vignettes just so that we can generate some discussion, and we will then look at what are the differences between when is AI helpful and when is it harmful. We will also talk about why automation or artificial intelligence is so attractive in a field like mental health or psychiatry. What have we seen historically over past 60 years when we started with ELIZA, and later now we are using the well-known large language models in treatment and early detection. What are the different concepts? I won't spend much time because I understand that all of you faculties and students are very well versed, so I won't spend much time in describing the concepts, but I would spend a lot of time on what are the current applications and what is the current evidence that has been generated towards those applications. And finally, I spent some time on talking about the risks, ethics, and current Indian regulations, and so on. So, as I was talking about this particular case vignette, this person who is a student who has an exam coming in about 2 weeks wakes up at 2 a.m. in the hospital, and he has symptoms of racing heart, he has symptoms of palpitations, sweating. He can't stop thinking about the exams that are coming. He keeps thinking that he must definitely fail, he's not well prepared for the exam, and thus he's not able to sleep. Now, what does he do in such situation? What he tries to do is that he can't call at home at 2 a.m. because what would you say? He's very ashamed of it. He doesn't want to say that I can't sleep in the night. I'm worried about whether I'll pass or not. And even though there is some psychological clinic available or some helpline available in the college, he knows that if he goes there, people will notice that he has sought help for some mental health issue, and thus he would be stigmatized. What he does in such situation is that he Googles as to what should I do. Google directs him to an app. The good thing about the app is that the app circumvents all these problems that he had thought of. App does not shame him. There is no shock value. App accepts whatever he talks about, his feelings and what he's going through. App is available all the time. App does not sleep. It's always awake. And of course, it's private. So there is no reason for him to be worried about people getting to know about what is going on with him. He tells the app what is going on with him. What fortunately happens is that the app tells him that whatever is happening with you may be a symptom of anxiety, and this particular thought process is called catastrophization, in which you think the worst possible outcome and keep focusing on that. But app does not diagnose him and then tells him that if you want, I can give you nearby counselors that can help you, which are online also available. He feels that he is being understood, and then he reaches out to the counselor next day, and things get better. Now compare it with the next case vignette, which is vignette number 2. This is another student, let's say a management student this time. And now what has happened is that he has recently started noticing that things are going a little fishy around him. He sees that he has noticed that the same car is waiting near his hostel since past 1 week. He has seen the same people whenever he goes for a coffee or whenever he goes to the canteen, who are talking around him. And thus he starts believing that he is being watched. He again goes to the phone, opens a chatbot, and tells the chatbot that this is what is happening with him. And why am I seeing the same people again and again? Why am I seeing the same vehicles around me? Am I being really watched? Now again, this system is also very warm. It's not cold. It does not shut him down. However, what this system does, because it is unregulated, it actually affirms his beliefs. It starts telling him what are the possibilities that are happening, that you may be actually watched. Some people may be actually keeping a watch on you, or some people may be trying to harm you in some way, and keeps accepting whatever the explanations that the student has. Now what happens is that though the person becomes a little calmer because he is not very agitated, and there is some system which is helping him to understand what is going on around him, but he never seeks help from a psychiatrist. He never goes to a psychiatrist, and gradually his belief that somebody is watching him, somebody is trying to harm him, keeps being reinforced by this chatbot. Now, if you go to, if you are using YouTube, Instagram, etc., or even in US they are using TikTok, this is a very common scenario. There are so many podcast episodes that are there about a similar kind of situation in which actually a client who thought was going for a therapy with her psychiatrist started believing that the psychiatrist was in love with her and he's trying to manipulate her, etc. And she first went to ChatGPT, then went to Claude, and then how it kept escalating, and then all her belief systems were actually strengthened rather than helping her seek more help. Now, what has happened here is that because he went to a chatbot, the chatbots, as we know, are very, very fluent. They are very warm, they don't pass judgments about what is happening, and thus they don't have any responsibility also. Now, what I wanted to understand and what I want to discuss is what is the difference between these two models. And if we understand the difference between these two models, more or less we understand how artificial intelligence can be successfully used in seeking care or in early identification in mental health. And that is going to be maybe the gist of today's talk. In the next 45 minutes, I'll be talking about this particular area, that how certain AI interventions or certain machine learning mechanisms are probably better or more evidence-based rather than certain others. So if you look at the same two things, the first case scenario that I talked about, you can see that the bot or the app that you used had a very, very bounded task. It was specifically for a particular task. What it also did is that it involved a human element. It escalated the matter, it did not diagnose, and it told the person that there is a person or there is a counsel and help that's available for this particular problem that you are going through, and it did not directly give a diagnosis or start treatment for this person. Thus, caring for this person was more important for this particular app rather than diagnosing or rather than engaging this person. Wherein the second app, that second example that I gave of a chatbot, there you can see that the task was not very circumscribed, it was an unbounded task, and there was no escalation mechanism, especially if a person starts talking about something that may not be appropriate. There was no challenging of these thought processes, and thus there was delay in the care that should have been given to this particular second person. Now, both systems, in terms of their models, were very warm. They were not very cold. They were not refusing what the person was saying. However, only one of them was safe, which was the first one, because it did not diagnose, it did not keep reinforcing their beliefs. However, escalated to an appropriate human evidence. And thus, the problem here is not that of a model. However, the problem is what is the design, what is the architecture of this particular app, and that is what is going to matter when we talk about artificial intelligence in mental health. So the question is not really, does AI work in psychiatry? That is a question that needs to be answered maybe in a few years down the line or a few decades down the line. What we need to answer right now is, if AI works, which task is specific to the AI, and if there's a backup that is needed or an escalation that is needed, what kind of backup or fail-safe mechanisms that are in place if it is needed. And thus, this particular distinction between these two kind of models is what is going to be today's discussion about. Why are we talking about this? Why is it required in mental health or psychiatry in particular? Is because of the numbers that are there. The global burden of psychiatric diseases or mental illness is huge. Roughly 1 in 7 people, this is based on the WHO studies on global burden of disease, roughly around 1 in 7 people has a mental disorder, usually a common mental disorder and rarely a severe mental disorder. And in 2019, when the study was done, it looked at around 970 million, that is 97 crores of people worldwide are affected by mental illness. About 1 in 6 years, now if we look at it in terms of disability, every 1 year out of 6 years lived in disability is attributable to mental illness. Severe mental illness not just cause disability, but people with severe mental illness they die much earlier than general population. They die 10 to 20 years earlier. So this is not just about a person having an illness, but this is actually a mortality issue in which people are dying because of illnesses, especially severe mental illnesses, because of usually suicide. Around 720,000 suicide deaths happen per year, and majority of them, about 3/4 of them, happen in low and middle income countries. And in such countries where suicide rates are so high, 75%, three-fourths of depression goes untreated. Now, looking at India, especially in India, there was a study that was conducted by NIMHANS with the help of, under the guidance of Ministry of Health and Family Welfare, which is called the National Mental Health Survey of 2015 and 16, and that looked at prevalence of mental illnesses. Prevalence of mental illnesses was more than 10%. So every 1 in 10 people in India had some or the other mental illness. Lifetime prevalence, so this 10.6 is the currently ongoing. If you look at lifetime, anybody has had mental illness or not, the prevalence increases to 13.7%. At this point of time, about 150 million, that is 15 crore of Indian population needs active care for their psychiatric illnesses. Global burden of disease, again a study done by WHO, which is done specifically for India, talks about much larger numbers. It talks about almost 200 million population being affected by mental illnesses and requiring psychiatric care. Overall, if you look at, so these many people require care, how many of them get that care? The numbers are very, very small. If you look at this is what is called as treatment gap or mental health treatment gap. The treatment gap is 84.5% for all. So out of these 150 million or 200 million, whichever figure you would like to see, almost 85% of them do not get the care that they require. And this is the attraction of AI, or this is the attraction of scalability that we have. In terms of the specialists that we have available with us, we have about 0.75, that is not even one psychiatrist in India for 100,000 population, which is very, very meager, and that's why no kind of training or no kind of increased number of seats of, let's say, psychiatrists or psychologists or mental health professionals is going to serve for this 85% gap that we are looking here. And thus, that is the attraction wherein we look at how we can scale, or in such a resource-scarce country, how we can implement AI and bring in artificial intelligence, machine learning paradigms in identification and treatment of population. Now, reinforcing this gap that I talked about, 84.5, it is not uniform. You will see that for common mental disorders, the gap is around 82%. As the disorders become more and more severe, the gap actually becomes more and more, or higher and higher. What it means that the severer the illness, the people who require more support are not getting support for various reasons. It may be lack of access, lack of awareness, lack of psychiatrists, stigma that they go through. But what we see that the more the people who need it the more, the less they are getting at in India. And this is why this field, especially mental health, has attracted the attention of AI. So what we have just looked at is the unmet need for mental health disorders or mental illnesses for treatment, for identification is huge, and just increasing the working people, just increasing the number of mental health professionals would not solve this problem for decades, if not for centuries. What is also important to know that the data that we use as mental health professionals for early detection, diagnosis, etc., are already available, and these data are about text. These data are about the history that they give, the speech that they use. Right now, a lot of data is being used using various sensors, wearable devices, mobile phones, etc., as well as electronic health records that India is coming up very, very fast right now. Also, a lot of tasks that we do has a lot of pattern recognition. So we look at patients, we look at what are the symptoms that we are looking at, we look at how that symptom is seen in that particular background of this patient, whether in his culture, in his surrounding, is this a symptom, is this an over-the-top reaction to something that this person has had, and thus a lot of tasks can actually be automated because they don't have it's a work of pattern recognition, and thus does not necessarily need a human judgment. What also is very, very important is that, as I mentioned previously in the first and second example, that the stigma related to mental illness is very, very high. Nobody wants to go to a mental health practitioner or a psychiatrist. Nobody wants to make it public, and thus the privacy or the safety and security that this gives is very, very attractive for even patients. We also know that nowadays there is hardly any cost if you want to start an app for, let's say, treating anxiety, treating depression. there is hardly any cost, and there are right now, of course, in July 2026, we have come up with some guidelines how these software will be regulated. But till then, there was no barrier to distribution. You can just put an app on Google Store or Apple Store, Google Play or Apple Store, and that would be available to all the population. However, this particular, which we are finding as the good points, are exactly the points because of which the cost of every error, the cost of every delay is going to raise because of the very wide outreach and easy accessibility of these apps right now. Now, how did these? And this is not new. We have seen this in 1960s, and they started from 1966 when a particular program, ELIZA, was written by a person in US, a person known Weizenbaum, and he came up with this program which would imitate what the usual therapist would say based on the pattern recognition of what the clients would talk to them. Now, he was very surprised by it. He actually published a paper regarding it, and later actually started finding out that even though there is no actual treatment or there is no brain that is being used, and this is just a pattern recognition, the program understands or listens to what the person is saying and just responds based on what it has known or what it has been fed. However, even though people knew that there is no treatment, there is no brain being used, he saw that even people who knew about all this started confiding about their secrets, started confiding about their details, very sensitive details to this, and thus he became very alert and he became alarmed by it. And after that, actually, he spent most of his life telling people or telling the world about harms that this kind of systems can bring. That you would feel the connect immediately, you would feel that somebody is listening to you, but there is no brain behind it, and you need to be very careful about what you are talking to these systems. Now, in terms of treatment and early identification, in 80s and 90s, gradually we started using expert systems, especially for assessments, in which there would be questionnaires. People would ask those questionnaires using computer systems and would use the responses given to those questions to further plan their treatment, plan their interventions. Recently, in 2000 and 2010s, we started using machine learning models, and machine learning would start looking at what is the records available, what are the electronic records or the clinical notes that are available, and start analyzing those and giving some feedback as to what may be lacking in these notes and what is their understanding from these notes. As the smartphone from 2015, etc., smartphone became very common. Now, what it also allows is the passive data monitoring as well as active data monitoring. So, continuous data is being fed with and sometimes without your permission also, and thus this has enabled day-to-day recording of various data. I will be talking about this in the next few slides as to what kind of data is being used for coming to early identification as well as treatment of mental illnesses. And now in 2022, especially after COVID and the boom that happened after COVID, we have seen that so many models have come up for such kind of, so many apps are available right now, so many, you would see that so many influencers are actually promoting these apps without having the substantial evidence base, which can actually be harmful than being any use. So if you look at what I just told, if you look at what has happened in terms of timeline in the field, if you look at till 2020s, you would see that a lot of new models were coming up. We spoke about ELIZA, we spoke about various computerized assessments, we spoke about machine learning models, especially working on the electronic health records. But in the past few years, especially past 4 to 5 years, what is being promoted and what is being encouraged is regulating what kind of data is being used, regulating, coming up with various guidelines. For example, in India, we came up with a guidance document called SAHI. We have also recently, as I mentioned, CDSCO has come up with a software guidance, how medical devices are not necessarily hardware devices, but a lot of these software which talk about medical benefits also need to come under regulation. And thus, what we are going to see in the coming future is not newer models of using artificial intelligence, machine learning in treatment as well as early detection, but how they need to be regulated, what data needs to be given to them, and how this can be more and more patient friendly making sure that the data is handled ethically. As I mentioned, I will not spend much time on the core concepts. You all know artificial intelligence, machine learning, all these are very easy to understand concepts. I will be majorly talking about digital phenotyping, which has taken a lot of roots in US and now being used also in India for early treatment, early identification of symptoms, early identification of relapses. Now, what behavioral phenotyping is that day-to-day or even moment-to-moment monitoring of behaviors, various kind of behaviors, active as well as passive, which are taken up, and this data is taken up using your day-to-day wearable devices like your smartwatch, like your phones, etc. And majorly, and that is what is digital phenotype. Usually, the data that we give to, for example, if you go to a mental health professional and if they ask you certain questions, that is the active data. If they ask certain depression-related questions, certain surveys. However, what we are also going to focus here is that a lot of passive data regarding your geolocation using the GPS devices that you have around you, data about your movement, how fast or slow you are, data about sometimes how fast or slow you are responding to certain questions or certain things, how fast you type, how much screen time you are spending on the internet or on the phones or devices. All this data is being collected, especially in certain digital phenotyping kind of instruments, and being used to predict early relapses. Active data, as I mentioned, is based on the active inputs or active questions that are being posed, including active inputs that may be, for example, certain voice recordings that the clients may do there, and that can be put in these models. Now, even though it is very attractive, because now what we see is that the symptoms, especially in psychiatry or mental illnesses, they keep varying. Now, if I ask, let's give you a very common example, because I come from addiction psychiatry background. If I ask a person, let's say after 1 month gap or 1 month follow-up, which is the most common follow-up that we do, as to how many, let's say, drinks have you had over past 1 month, the answers are usually desirable answers. They generally underestimate what they have done. Or if I ask them how many days did you take tablets for, or how often have you missed your tablets, again there is a possibility that they will give the answers that they think I want to hear. And this is what is bypassed by using day-to-day monitoring, or what we call as ecological momentary assessment. Now, even though this is very good, what happens in such designs that even though the density of data points is very high, the interpretation of data may be very fragile. For example, if somebody has found based on the GPS tracking or geotagging that this person has not gone to various places as he was going, let's say, last month. Now, even though in certain patients that indicates that he may be depressed, or he may be psychotic, or he may be having some side effects, there may be so many other reasons for the same kind of a phenotype. That there may be, let's say, there is something that is happening around him. Monsoon has come in and that's why he can't go. COVID came in and there is lockdown. So it becomes very problematic to create a lot of inferences from these data points, and thus there is a need to have that human touch. Usually, whenever we are talking about human touch, typically, ideally, an AI integration or an AI integrated device or an app should have these following steps. First of all, we need to have a very clear clinical need. We need not look at what is actually prevalent in social media, what is being talked by a particular celebrity or an influencer, but actual clinical need that the patient has felt. We need to go for the further steps of designing the model, data governance, how this data will be used, who is going to be the escalation matrix of this particular data, model development using the engineering tools that we have, and internal validation. Typically, all the apps or all the models that we have follow through with this. What does not happen is the next subsequent steps, which are actually more important. Steps of external validation. So you have come up with a particular device or a particular model using the population that you had at your hand, but how is this particular model going to fare if the population changes, if the language changes, if the hospital changes, if the disorder changes. So some kind of external validation is extremely important for all these models. what also needs to happen for these models, especially to increase the evidence base, is to have a prospective trial. Now, what happens typically when a model is developed? It is tried when we do an internal validation. It is tried on patients who are already diagnosed as healthy, or who are already diagnosed as cases of people having mental illnesses. Now, in prospective trials, when we are actually looking at the AI tools that may screen the people, that may identify a particular disorder, we need to have a prospective longitudinal data for that. We also need to have a very, very clear regulatory review as to, in case something came up, somebody has told about some suicidality, somebody has told about depressive symptoms, how that is going to be handled by this particular model. We also need to integrate available workflow that is available, and then post-marketing monitoring is also very important. And I'll give you a few examples, real-life examples from real apps that were actually very good, but did not do what they were supposed to do. And this kind of monitoring is important because it feeds back to this particular chain of events and keeps refining the model so that it is more and more useful and not harmful. So talking about validation, as I mentioned, internal validation is very important. However, external validation is even more important. How will this particular model fit in a new hospital, in a new language, in a new device? Let's say it does. What if people don't have the smartphone that you want this person or your model wants? Also, it's important how these models or how these screening tools calibrated. Now, what happens if a particular score, let's say out of 100, a person scores 70? Does it really mean that this person has a particular illness, or what does it indicate? So unless that calibration is very, very strongly founded, we are looking at very arbitrary values. We also need to look at how data sets shift, how newer models come up, how newer languages come up, and how your particular model is going to adapt to these newer data shifts that happen. Also, this fairness, justice is something that we need to look at, that this model did not be particularly curated for a particular population. Let's say an English-speaking population with wonderful smartphones or iPhones in their hands. How does it do in a family wherein a same smartphone is shared by 2-3 people, or a family has one single phone? So how in certain models may function in some various scenarios or subgroups need to be checked at, and that is exactly the reason to there are these two reporting models that are available, which is tripod plus AI and probas plus AI, and this is the reason why they exist. Again, why we are talking about all this, why we are talking about these kind of data points and accuracy of data points, because accuracy did not necessarily be equated to usefulness. A model may be actually very accurate in detecting certain symptoms, but unless it is linked to a particular outcome for a particular set of patients, it is not really useful. So what we usually look at, especially while building a particular model or designing a model, is how is it going to discriminate between people who have symptoms and people who don't have symptoms, but whether it actually leads to better decision making in terms of what kind of care is provided or what kind of interventions are provided, it may not be very useful. What is important to know, that even though what these models are looking at prediction or finding correlations, whenever we are talking about psychiatric diagnosis in particular, psychiatric diagnoses are not just based on a symptom checklist. We look at how is the distress to this patient, how much of functional impairment has happened because of these symptoms, how much of a problem that these particular set of symptoms pose to this patient, his family members, as a society, how long these symptoms have been there, and what kind of treatments have worked, not worked, etc. So diagnosis especially needs a lot of context. Prediction just needs or finds correlation between whether the symptoms are present or not. And thus, it is important to use these only as screening tools and not necessarily as diagnostic tools. And this is also seen in a lot of studies, especially in terms of psychiatry and mental health related studies. We have found that the larger population studies that are done, they generally fail on accuracy measures. Their accuracy measures are much less compared to smaller population studies or compared to less rigorous studies that we have seen. And thus, we need to look at whether we are looking at just discriminating a particular population from other, or whether we are connecting it with a better decision-making system, etc. And thus, coming to the application part of it, And the most studied type of application in terms of AI related applications and in psychiatry are the screening and early identification applications. These are probably the most likely to be successful in the coming future, and a lot of systematic reviews have found the pooled area under curves for these these kind of apps are roughly 0.79 to 0.96, which is very, very high. Especially in illnesses like depression, the models that use speech or multimodal monitoring, including wearable devices, including active and passive data, they are able to distinguish people who have depression from those who do not moderately well, which is very, very good. However, what we have also found that most of these models have used very small data sets, very stringent guidelines in terms of inclusion and exclusion criteria, and these models were based on, as I mentioned, case control data, that it was used in patients who were known to be patients versus healthy controls. And this particular design may not survive a typical clinic population in which we do not know whether this person has symptoms or not. We do not know whether this person has come read about certain symptoms, whether he has seen any particular video by an influencer in which influencer told about symptoms. This person also felt that he has same symptoms and has come to you. How much of influence a separate Google or a chatbot or an AI engine has got on his symptoms, whether he is telling the symptoms, and thus it is not just about listing out symptoms, but also understanding this particular illness, understanding this particular person. And thus the best framing of such models may possibly be as helping tools for screening of diagnosis and not necessarily diagnosis alone. As I mentioned, diagnosis is not may not be the best way of going forward with this at this point of time, because diagnosis rests on, or diagnosis is done based on the history, based on the functional impairment of the person, and especially in Indian context, if you look at a lot of available AI-related apps and AI models, the language that we use to express our distress is completely different than the language that is used in Western world. Our English, how we use, is different. We use English in very different ways, and these current existing models are not able to survive it. And we have recently done a study with Wellcome Trust of USA, in which we found that we are not getting even 20% success when we look at identifying idioms of distress, or understanding whether this person is talking about depressive symptoms, anxiety symptoms, and whatnot. We also use, almost all of us also have this way of using language in which if an AI tool has to pick up that language, a lot of code switching needs to happen. We use a lot of English, we suddenly put in our native language, we may use 2-3 languages at a time while expressing our distress, and thus that kind of code switching does not happen in these models at this point of time. And thus AI, what it can be used is if I give it a lot of summary statements, or my clinical notes are available, which are written by another doctor or another mental health professional. AI may be used to summarize that. AI may be used to give us more clues as to, okay, you need to ask this question also. If this person is depressed, you need to ask about whether this person is having any death wishes or any suicidal ideations also, whether there is comorbid substance use. So any kind of omissions AI can bring up. AI can be helpful in, let's say, understanding or helping me making the decision better, rather than giving a meaning to the person's suffering. And that is where we are gradually shifting. Now, one of the probably the most promising field in which AI was used is suicide risk prediction. Now, again, reviews have looked at the EHR, or electronic health record based machine learning models, and then they have an area under curve of about 0.81 to 0.86, which is amazing. We have also seen that if you look at prospective trials, so first line was about the retrospective available health records, but if you look at prospective trials also, the number needed to screen to pick up a person with suicidality were reasonably okay, and thus the AI models were able to tell us that, okay, I mean, out of these 1,000 patients that we have to screen, maybe you can look at these 100 or 200 patients first because they seem to be scoring a little high on my radar. And if you look at these numbers in scientific, in computer science, these numbers are fantastic. There is no discussion any further. If you get such AUC numbers, these models have to work. And in psychiatry, however, it does not. The reason for it, I gave you that whenever even the specificity and sensitivity numbers of 80%, 90%, etc. won't work because the events, especially the sentinel events in psychiatry, are very, very rare. And the rarer the event, the worse the model will perform. I'll give you a very, very easy example, easy to understand. Imagine a scenario where there are 10,000 patients, you are a professional, you have to screen 10,000 patients, and you know that in these 10,000 patients, the known base rate or the known rate of a particular event, let's say in this particular case suicide, is 0.1%. So you will see that out of these 10,000 patients that you have to screen, 10 of them will have some suicidality. Now, if you give a model that has, let's say, 80% sensitivity, that is, the 10 out of 10 people, it will successfully or easily get 8 people. So you can see on the left side, 8 people will be flagged high risk by this particular model, where 2 people, the 20% which is not there in sensitivity, will not be flagged. Now, if you look at the same, so total numbers again, so 10 people in which event occur, the left side column. So event does not occur in 9,990 people. Now, if you subject specificity into this particular model, let's say a specificity of 90%, you will get about 992 people in which there was no event, no need to flag this person, but the model flagged those people. Now, what is the problem even with such high numbers of 80% and 90% is that if I use this model on 10,000 people because I want to make sure that these people are screened out early and I pay more attention to them, to get these 8 people, I need to actually screen 992 people. Now, if you look at automating this particular scenario, so here at least I am there, I will ask these 1,000 people and try to find out who are the people who are having a particular illness or having suicidality. If you automate this, or if you make sure that there is no escalation mechanism, 992 for 8 is huge. You are actually looking at 110 or 112 patients per person that you have to screen to get one person, which is again very, very low. So, and that is the, so you have seen here that the false alarm rates that will be generated will be very, very high. Later, what happens is that there is fatigue that develops. That okay, this device has beeped that this person may have high risk. I looked at this patient, there was no suicidality. Next patient, I looked at it, no suicidality. Next patient, I looked at it, no suicidality. Gradually, I will start feeling fatigued. My rigorousness of looking at what, I will keep thinking, okay, this device just seems to be beeping without any reason. Even though it has a very, very high specificity and sensitivity, it fails, especially when the event, the sentinel event itself is very rare. And this is called as base rate fallacy, which is very, very common. Even though we want it to be used in such events, it is difficult to use. And if you look at that as the weak link, crisis chatbots are probably the weakest links. We have seen examples, and you would have read about these things wherein the chatbots, even though there were very clear-cut signs and signals of distress and people looking at various suicidality suicidal people looking at ways to commit suicide, chatbot at least 3-4 years back were actually helping these people. Right now, there are good enough regulatory mechanisms that the chatbot will immediately flag it to the person, reach out to the agencies which will help in such people. But in 2025, when there was a systematic review that was done for 29 such chatbots, none of them met the bar. Now, what they are able to do in terms of especially crisis management, if there is a very clear-cut understanding that I am feeling suicidal or I am having these kind of thoughts, chatbot is able to pick it up. But that is usually not the case in people who are having these kind of thoughts. They don't want to talk about it. They tell things like, okay, things don't feel of any use. I don't know why I should carry on with this. I should quit or I should give up anything. So these kind of ambiguous or indirect signals, none of the chatbots were able to pick up, and thus they actually started giving very inappropriate or actually unsafe or risky responses. This was done in 2025. They did a follow-up evaluation again with the same chatbots, whether anything has changed, whether these chatbots are able to pick up these kind of crises. They still found a lot of inappropriate responses by the chatbots, especially in cases where the symptoms or the chat that happens is not very clear and it is a little ambiguous, which would otherwise alert a mental health professional, okay, why is this person talking about these things? Why is this person talking about, let's say, quitting everything or giving up everything, or sometimes elderly people talk about writing their own will. Why is this happening? A chatbot was not able to pick up, and thus AI may at this point of time help us in telling that these people may be useful to be screened and they have high risk. However, they will not be able to or escalate it to the next line of management, escalate it to the mental health services. They will not be able to hold to a crisis or catch a crisis as soon as let's say a mental health professional. And thus, escalation may not be a feature in these. Escalation is the outcome of the product that we are looking at when we are using AI, especially in crisis chatbots. Now, when we talk about chatbots, we are actually looking at 4 different types of chatbots. One example I just gave was that of crisis chatbot. But right now, we have 4 different types of chatbots. First of them are the earliest chatbots that came out, chatbots like GoBot or Visa, which was rule-based self-help. So if a person talks to these bots or types something based on what is the condition or based on what are the keywords that these people have used, it would give a typical or a usual or a standard response to these people. So these were the rule-based self-help. The majority of the guidelines or majority of the evidence is on these rule-based chatbots. Second would be constrained hybrid, in which there will be a clinical content which will be already available, and especially if there are certain keywords or phrases that the person uses, there will be a human escalation or the clinician team will be alerted about these kind of chats or these kind of talks. Next would be fine-tuned generative, and this is what we are trying to develop, is that, for example, one of the bot that is available is called a Therapod. What happens is that if there is a person who has reached out to this bot, has typed something that is distressing to that person, it immediately reaches out to an actual human clinician team, and based on the responses that these clinician team give, the Therapod talks to the patient, and this is an expert advice Therapod. Gradually, we are trying to incorporate a generative kind of AI into this, so that we are able to understand, we are able to grab the keywords and phrases, and actually increase our vocabulary of grabbing these phrases from any general chat. Now, what is the most commonly used, as I mentioned, something that you would see on Instagram, something that you would see on YouTube, are the general purpose large language models. There are no clinical guidelines. These are bots that are not subjected to any standard rigorous testing. There are no evidence available for them, and these are the most problematic ones. Yeah. I will start with a few of the case studies of these apps or chatbots that were used. One of the first ones was Visa. This came in last decade. It was founded in Bengaluru and has, if you look at Play Store or Google Play Store, it has more than 6 million users. What it offers is a very structured cognitive behavioral therapy kind of responses based on the what the human coaches are doing behind, based on the chats that they get. It has actually gone and has underwent a lot of peer-reviewed trials. It has a lot has been published about Visa, and the US FDA has actually given it a designation of a breakthrough device. That Visa is something that is the need of the hour, or that is something that needs to be used by people. In 2024, we did actually, when NHS did the trial about Visa, they found that people who are using it, 6 million of them, actually like this device. They find that they find it very useful. However, when they looked at the data behind what appears, except for the acceptability and likeliness, etc., when they looked at whether Visa was able to demonstrate or treat based on its CBT pathways, treat depression, it did not find any difference between no Visa versus Visa, and thus just liking a tool based on fluency, based on interaction, based on what the chatbot or what the app is telling, saying that it is useful may not be a correct clinical endpoint. We are looking at how this person was treated or what kind of benefit was given to this particular patient because of this bot or because of this app. Now, one case study that actually failed miserably, which was this is called as PESA. It was used by the NEDA, which is National Eating Disorders Association. It came up in USA again. They came up with this particular model, and it is a helpline. US used to have a helpline. What it tried to do is that it tried to remove the humans from that helpline. Later, they found that it is because of these humans who were carrying out the helpline, attending these helplines, tried to unionize, and then they were tried to be removed. And it was replaced by chatbots because they thought, I mean, what are they doing? They're just using or helping with people with the help of helpline. What this bot actually started telling, what this chatbot actually started telling patients is certain advices like diet, how diet restriction has to be done, how they need to calculate their calories, how they need to look at how many calories they are eating. They need to check their weights again and again. They need to look at how thick their skin has become because of fat deposits using skin fold calipers. Now, looking at it as a third person, it would see that, okay, if somebody wants to cut weight, if somebody wants to become healthy, this is a very good bot. But if you look at the purpose that this bot was, a chatbot come up with, was for eating disorder. For any person with, let's say, an eating disorder called anorexia nervosa, all these suggestions are very, very dangerous. These people are already very, very meticulous or very neurotic about what they eat, how many calories they have eaten. A lot of times they think that their weight is too much, even though they are very, very thin and frail. They start inducing vomiting to not eat. They try purging. They use things that would induce diarrhea, all those things. So giving such kind of advice was not for the good, and it actually harmed people. And thus, even though chatbot was brought with the purpose of removing the human element or maybe punishment to people who are trying to unionize, it was taken off within a week. And again, the problem was not what kind of suggestions were given. Problem was who was it given to, how was it governed, what kind of population was it speaking to, and that is something that we need to look at. Thus, automation that was brought in to cut labor, it did not work and had to be taken away. Next two studies are about WOBOT and TheraBot. This is something that I spoke about in the timeline. WOBOT again came up in 2017. It came up with a small trial and did show short-term improvements, especially in depression and anxiety score. However, in clinical studies, what they found that the population that it was used was a very, very narrow population. It was used just for 2 weeks and looked at what is the difference pre and post 2 weeks of using it, and thus it may be used maybe as a supporting tool rather than a treating tool or a therapist. Second thing is TheraBot, which came up in 2025. This is a fine-tuned generative chatbot. It generated its own responses and it actually had in a randomized trial reasonably meaningful differences between patients who are using TheraBot versus patients who are using waitlist. Now, this is something that I want to maybe briefly speak about. In trials wherein you are looking at this is my intervention, and when you are trying to compare it, you either try or compare it with what is available as a gold standard, that this is the standard treatment, and you look at how your treatment compares to that. A lot of times, therapy-related outcomes may not be judged very well in such kind of models. So, what they compare it with is people who receive the particular intervention compared to people who are wait-listed to receive this. People who are not actively given anything, but they will be given in subsequent time, and they compare it with wait-listed, and that may be a problem in these therapeutic kind of chatbots and may need further supervision. Now, what is a better case study and something that we need to look at and we may feel a little proud of is this particular case study of Practice Pal. This is a Hindi chatbot which was developed in Madhya Pradesh, and what it tried to do is to support behavioral activation, to give certain activities to people who are going through distress, who are going through depression. And what it tried to do is that during therapy sessions with an actual therapist, it was being used as a between two therapy sessions, whether the homeworks that were given by the therapist, whether they were done well, Therapists a lot of times asked to do tracking of their activities, tracking of their moods. So this particular chatbot would help in that. And this is something that is very, very useful. This is something that has actually helped a lot of people. However, even though the architecture as well as governance was very good, what it found that a lot of people started having problems because chatbots would need a very broad bandwidth, as well as it needs people to respond to a chatbot. It needs them to be literate and they need to understand what questions are being asked. And they were the problems that are inherent in India, that we do not have the kind of bandwidth coverage in rural areas as we have in urban areas, and many areas where we do find a lot of problems. People may not have adequate literacy to engage with these kind of devices. Thus, again, we need to use them as AI supported care rather than replacing human elements. However, this is one of the wonderful models, especially used because it is done in Hindi, a local language which is understandable by a lot of population. So coming up with more and more models of this kind which use indigenous languages is something that we need to focus on, and we are doing such kind of work. Now, if you don't know, these were for common mental disorders using therapy, etc. In severe mental illnesses like schizophrenia, like bipolar disorders, one of the tasks that is taken up by AI is that of finding when the symptoms worsen. When this person who is stable for this current time, when are the symptoms coming back? Because that is the period when you would like to intervene as a mental health professional. You would like to catch them when the symptoms are just starting or very minimum before it actually becomes too extreme, too severe, which would need very intensive treatment, sometimes admissions to the hospital. And this was done by Harvard Medical College in Boston. They came up with this particular app called MindLab, and the trials were done in not just Boston but also in Imans as well as Bhopal. This is also looking at, so the team that is looking at this MindLab also does a lot of work on digital phenotyping. So this MindLab app is installed in the mobile phones or smartphones, and a lot of passive data as well as certain active data is fed to find out if there are any anomalous behaviors. Behaviors like reduced blink rate, behaviors like increased response time in typing, geotagging and GPS related reduced movements, or for example, what they also try to look at, and I have done a particular study looking at in substance use disorders, looking at parameters like if the person is having training or not, if the person is taking regular medications or not. So all of this data is useful on all these anomalies. If there are any deviations from the usual patterns, they are. If we have found that these kind of anomalies almost double just a week prior to an actual relapse or actual visit to the with the increase in symptoms. So what we have found is that not just active data that we collect, a lot of passive data also improves the overall risk detection or relapse prediction. What it is also useful because it improves engagement for the patient, because the patient does not need to remember all these symptoms. They are able to give those answers then and there. This also, MindLab also has a very, very clean path and also an escalation pathway in which people who are doing this study are given a trigger or an alarm if there is any deviation. However, we need to also be very sure and we understand that a lot of data that is collected is actually linked to a response or an escalation. Otherwise, it is just surveillance. Why are you actually tracking this person's GPS location, etc. So that is something that we need to look at, and this is especially true for cases who have a lot of huge treatment gap, that is addiction and substance use. What are the typical targets in such apps is when the person relapses, let's say on alcohol or any narcotics or opioid use. Are there any overdose risks in this person? Are they planning to go to a person? So this is based on the GPS tagging. Are they visiting locations where they used to consume the substance? What a recent review, a systematic review has found that to predict all these things, including craving, including relapse, including overdose, the most robust factors are not necessarily biological or history related. They are usually psychosocial. Social problems like housing or homelessness, social problems like unemployment, problems like a legal case, legal status, police cases, stress that is happening in the family, has a lot of bearing on whether the person relaxes or not. Now, uh, so a good AI would actually look at not just internal motivations for consuming a substance, but also all these factors, whether this person has living arrangement, whether he has stress, whether there are legal cases. The problem with that is that if you start surveying people about their employment, about their housing, about their legal cases, all this data, if it leaks, it is a problem because all this data can be misused by someone, and thus, especially by law agencies, especially by employers, if somebody finds out, especially by insurance agents, etc. So, if people start looking at this data, it can actually lead to less care than more care if this data gets leaked, and thus predicting is again something that they should focus on with a lot of ethical issues rather than just diagnosing and trying to predict attacks. Probably the most important use case for these AI related models are documentation related, because again, for with more and more awareness about various illnesses, with more and more legal cases, people who are being very careful or people who are litigious, documentation has gradually started becoming more and more important compared to a few decades back, and that's why medical scribe is something that people have started looking at as an actual job. And what they do is they look at, they listen to a particular interaction between doctor and a patient, and then they make meticulous notes about it. And this particular kind of a thing can be taken up by AI, and a lot of speech to text models that can be used. Again, that is something that would also need, for Indian population, we had to also look at what kind of code switching will happen in between when people are using two or more languages, not just sticking to one particular language. However, there is good evidence that, especially in 2026, we have a study which has looked at what kind of notes or clinical notes, what kind of information is taken up from that, and what kind of behavioral changes happen when the doctors actually look at these notes that are done by AI or chatbots or scribes. What they have found that compared to the notes that were actually recorded before with humans, compared to that, AI related models are able to track or gather more symptoms. Now, that should have actually led to more diagnosis and more treatment. What they found is that the management that was done for more symptoms was actually less. So, even though more symptoms were found, the doctors actually ended up giving lesser treatment than what they were giving before. So whether what is it that is actually deciding these clinicians' behavior needs to be studied. But this is an interesting finding that we have found. Finally, this is something that I have been talking about: unbounded AI companions, wherein and the public uptake for this, as I mentioned, millions of people have started using these kind of apps, these kind of chatbots, these kind of AI tools for talking about their symptoms, talking about very sensitive details about what is happening with them, their personal life. And even though there is no very clear-cut evidence, the uptake of these companions is very high. What we have also found that because, and the uptake is very high because people are not willing to talk, especially people with severe mental illnesses like schizophrenia, severe mental illnesses, or substance use disorder. They do not want to talk about their symptoms to any other person, and that's why talking to a chatbot or talking to a companion like this is very, very attractive for them. However, as I mentioned, that these chatbots are not very well regulated. There are no clear-cut escalation pathways. They actually do not pick up a suicidal intent or even delusional prompts in which people may say that they may develop suspicion that people are watching me, people are trying to harm me, etc. WHO also has given a guideline in which they talk about hallucinating AI engines or AI engines that suddenly record a symptom that you have not spoken about, or suddenly talk about or give or record something that was never discussed. So that is something that we should be very careful about. We should also be careful about the privacy of what is being taught as well as the biases that may come up. Again, the latest reviews do not support standalone LLM at all. There are no evidence for this. These are not scientifically proven. However, what we have seen that people are getting attached to these models very much, and thus, which is actually rather than getting more or faster help, the help seeking in such cases, because they get someone that listens to them, the help seeking is actually delayed rather than an early help seeking. So current evidence map, as you can see here, right now what we have found is that maybe at this point of time, AI tools may be used as adjuncts for, let's say, documentation or rule-based CBT help. In some conditions, a pilot is being done, especially for screening support or decision-making support, etc. Certain models can be used only for research, for example, finding out risk for psychosis. Completely and currently, the evidence suggests to avoid standalone chatbot crisis response apps or autonomous AI therapists. Now, what are the risks if we actually indulge in these? As I mentioned, there is an automation bias that the clinician starts trusting the machine more than themselves, or starts trusting it more, starts trusting the responses that the machine gives more than their own judgment. A lot of times patients start trusting the machine more than their own judgment or even what doctor says, which is called as anthropomorphism. Now, anthropomorphism means that they start feeling as if machine is a real person because of the various fluent responses that the machine gives. As I mentioned, the problems with hallucinations are very common and very something that we need to be aware of, that a lot of times just a hallucinated note can become a permanent mark in the person's electronic health records. Also, a lot of these standalone apps overclaim what they are able to do rather than claiming it to the available evidence that they have. A lot of dependency, attachment with these apps, and thus delay in the care is something that happens. And because more and more AI tools are being used, we have seen that gradually the skill to talk with patients, right? Gradually the skill to actually understand their symptoms, to express empathy, all these skills will gradually get eroded if we focus too much on or depend too much on AI. And this is something that we need to be aware of. Again, this is not something that everybody, all of you must be aware of it, that whenever we are using, we need to stick to these 5 anchors of ethics, that the autonomy of the people, what they are getting into, that they are talking with the machine, is something that they should know. They should not consent to something that they don't clearly understand. They should be able to withdraw their consent at any point of time. There should not be any, so non-maleficence, there should not be any harm. If a person talks about suicidality, if the person talks about their symptoms, making sure that there is if the system fails, it should fail safe, it should escalate it rather than being silent about these symptoms. No people should be excluded, it should be fair, it should be just. Also, the dignified handling of this data is also very important. And again, the problem with especially sensitive data is the price of big data is very high. So there is always people may start feeling that there is a possibility of getting a lot of money out of it. So that is something that we should be aware of, and we should be accountable for the same. India especially has wonderful opportunities since 2022 when the Telemanas, this is a one-of-a-kind program in which we have started telephonic helpline for people with mental health care needs. We have developed 53 cells across 36 states and union territories in India. Since 2022, when it was launched, we have received more than 32 lakh calls in all languages, in 20 languages in India. We have also seen that the digital mission and ABHA kind of schemes, which look at the identity of various patients, identity of doctors, therapists, various registries that we are maintaining digitally, something that is being very useful in giving more and more care for people who need this care. We of course have a very huge and successful district mental health programs, which has reached 767 districts. Again, this SAHI is something that came up recently in February, which is a health-specific AI strategy that is being given by the government of India. And thus, we need to gradually include all these kind of schemes and all these digital kind of technologies into our public infrastructure so that they reach to the grassroots level. As I mentioned, in terms of regulations, we have the Mental Health Care Act, which looks at how the person's information is used confidentially, how their records are kept confidentially, how the patients themselves have a lot of access to these records at any point of time. We also have a recent DPDP Act of 2023 and DPDP rules of 2025, which look at the process of data handling, data governance, and of course consent and erasure of data. CIDISCO, as I mentioned, has come up with a new guideline recently in July 2026, which has also looked at medical purpose, has not limited with medical devices, but medical device software is something that has come up, and these are the various opportunities in India. The barriers, however, as I mentioned, that Western English data does not pick up English or Indian idioms or distress, even if they are used in English. Where a lot of code switching happens when a lot of people talk, and thus that breaks off these Western English models that we have. We also find that in a lot of rural areas, the same device is being used with a lot of people. So a lot of passive data or active data may not be person specific, and thus a very, very precise intervention may not happen in a lot of families in India. We also see that the distribution of technology in India, especially that of smartphone, seems to be gendered, in which women have slightly lesser access to these technology compared to men, and thus we do not have an adequate representation of women in these data sets that we are trying to get through active and passive data. Of course, literacy and bandwidth limit is something that I just spoke about, and again, local validation or an external validation in various languages in India and various subgroups in India is something that needs to be done. Now, with this, I will come to the final framework that I would suggest, that whenever we are looking at a new venture or a new app or a model, these are the 5 things that we should take care of. Whether this is actually looking at an existing clinical need, whether what we are collecting is accurate and is it evidence-based, whether what kind of risks are we posing when we collect the data, when we give suggestions to people, and are there enough fail-safe mechanisms to escalate in case we find something. Is this model equitable? Is this given across all subgroups, all people of all gender, all socioeconomic backgrounds, etc.? What are the mechanisms to make sure of security and privacy according to the DPDP Act of 2023? This is something that I would skip for now. Future directions, we need to look at what are the various multimodal models that are coming up using various inputs, active as well as passive, to early identifying various psychiatric illnesses, early relapses, etc. Making sure that these models are based on local languages, making sure that these AI and the AI assistance is used very commonly in making decisions based on the screening tools that are available. Using these in available services like telemedicine is something that we may have to be used. Of course, as I mentioned, autonomous AI or autonomous chatbots remain unsupported by evidence. So AI at this point of time can be used as a co-pilot, but we can't give complete control to the AI. What it can help in is where the human judgment or human intelligence is not required. Taking data, interpreting data, summarizing data, organizing data, and giving some feedback to the human element that is involved right now maybe the best way, at least for the coming few years. We have to keep looking at what happens in the coming 4 or 5 years. Thank you so much. These are my. Thank you so much. If we have some time, anybody wants to have any comments, questions?
Thank you so much, sir. The talk was very informative and insightful. I just have a question. We have come up with national education policy, and state education policy. I just wanted to know how many mental health professionals were invited in making that policy. Why our education system is, not including any core subject related to mental health. I believe in something called mind your mind. That is very, very important. Physically, if we are a little weak also, if our mind is strong, we can again present ourselves in the best way possible. But physically we are fine, and if our mind doesn't have the health, we are completely weak. We are equivalent to, no existence. Okay, therefore we live in such a world, and advancement of technology is influencing all the generations in a negative way as well. And the need for mental health professionals is becoming more and more. But still, our children are, not getting that right direction to structure their mind, because most of the time parents are helpless. Because as you said, they feel more comfortable to discuss anything with a chatbot. They live in such a world. And see, if somebody has pressure or sugar, that is matter of prestige. Like, after certain age, if they have pressure or sugar, they say it like sometimes with pride. Okay, it's like that. But when it is a mental health issue, as you rightly said, people try to hide it. Even in this world also, people try. Why? And how? Why no effort is happening to fill that gap? That means the gap that society has when it comes to mental health. Okay, society gives a lot of importance for physical health, but mental health is more important sometimes than physical health. Okay, mind has that power. So, as a mental health professional, like, what is your opinion about it?
Thank you, madam, for these very, very critical observations that you have made. I'll take these one by one. Now, of course, we have seen that gradually the importance that is being given for mental health compared to, let's say, a few years back or a few decades back, gradually we are seeing that the importance that are given at various levels has increased. We can see that in the mental health program that has come up, the mental health policy that has come up recently, the school mental health program that is in the pipeline, various particular specific communicable and non-communicable disorders which are very commonly associated with mental health illnesses, they are being in talks. So I would not say that it is completely gone, but correct, and absolutely I agree that it is not to the level that the society as a whole would help or will be helped or benefited. Now, what we have found and what is being spoken to more and more is that rather than focusing on, let's say, an individual or an individual mental health or even a family and friends mental health, how we can gradually increase or start talking about wellness and focus more on wellness and how we can, including the mental wellness or mental health, how we can focus on that. And one of the things now, fortunately, I work in the family psychiatry services also. So what we have seen, and this is something that everybody is talking about these days, is that how we can bring back the values of a family. A family, as you have mentioned correctly, right now, if there is a problem with a person, they find the chatbot to be a readily accessible. Chatbot does not talk them back, or chatbot does not say, why are you calling me again and again, or you take care of this, or it is your boss who is talking, or I have my own problems. So chatbot does not say things like that, and that is the attraction of chatbot. But if we can gradually focus and bring those values, gradually focus on how the family can stay together, is something that is being spoken at all levels. I mean, you would be surprised that even last year I had a talk in Judicial Academy in Bangalore. The Chief Justice of the bench justice had come, and the topic for all those Judicial Academy was family values. And this has been noticed by all that because of various reasons. Now the nuclear family and desegregation of the family is one of the reasons why the help seeking, early identification in the family has not happened. That people have been alone, they have not developed the skills to talk to each other, they have not developed the faith in the whole system that this system will be able to help me if I have any problem. I can freely talk to them and then they will be able to support me. So that kind of what we call a social skill or social cognition, gradually because of nuclearization of family has come down. You would see, and this is something that even I said, when I was in my degree, let's say 12 or 13 years back, and how I see the current generation. So previously generation gap used to be actually generation, but now even in a few years we are seeing that because of various these social paradigms that we are now facing, we have not given those skills to the coming generation, and that is one of the reasons this chatbot or this AI or even screen seems to be the immediate trend for these people. So how we can bring these values back, how we can bring the values of society or these back, it may be by gathering together, maybe weekly, having a ritualistic meals, that is at least one meal per day should be together. So all these, even though at this point of time we feel very artificial, gradually we need to bring them back so that we are more making the generation more and more resilient, focusing on wellness, focusing on resilience, focusing on their capacity to handle this distress and capacity to not decompensate at the face of any small challenges is something that we need to start working on. Coming to your next question, why policymakers don't take psychiatrist opinion, I will not say that they are completely ignored, but
there are counselors at school level and like one counselor or sometimes two counselors
Yes.
at college level. But even now also like they give special sessions to the students to motivate them to approach the counselor, but still there is a hesitation because those who are going there are noticed in that way. But I don't think the counselor concept is working out there. Instead of that, like we are teachers. Same way, someone who regularly visits the class as part of a subject related to wellness, we can call it as wellness, something like that. Actually, that can directly or indirectly help an individual to grow up confidently and in the right direction. Today we are lagging behind. I think our system has to change.
and what the system tries to do is, I mean, this is something that is noted that if you just give this particular job to specific mental health professionals, we don't have it. We will not be able to catch them. So what ends up happening is that people who are already given a lot of work, let's say in schools, there are teachers who already have so many works, not just focusing on schools. I mean, right now I see that same teachers who get called in for population census also, same people are called for SIR also, same people are called for everything. And then because they have such a close contact with students, they are given more responsibilities. Just rather than taking this as a newer opportunity, many of the people are not able to take it up because of such a high workload. In communities, you will find there are Anganwadi teachers, there are ashas which are given a lot of work. And even though we want them to work because of such a brilliant contact that they have with everybody in their community, if you give them without incentivizing it and just give them that this is your additional work. So previously you were doing these 10 things, now you do 11 or 12. Without incentivizing it, they feel it to be a burden and they are not able to make or do justice with that. So that is something that we need to see, that who is the workforce that is going to do this job, and thus going back to the family, going back to the friends and going back to the communities is something that we need to look at, how we can engage communities, how we can make those frameworks stronger. So that's something that we may have to think.
Thank you, sir. Like when we depend upon AI a lot, definitely it is, it is putting down our cognitive ability, our intellectual capacity. So we should be a little conscious when we, depend upon AI in that. And as you rightly said, a mental health professional cannot be replaced by AI because there are n number of factors, behind that. Thank you so much.
Yes, sir. I will be facing some calls, like some student will call me for some suggestions, like is not prepared well, or is depressed. Like, what type of what I can suggest them for counseling?
So usually, as I mentioned, that people who are the first contacts, now that says a lot about what kind of teachers we have here. That a lot of students are able to reach out to their teachers for seeking help. One of the things that I would suggest is to be open. I mean, a lot of times if people talk about, let's say, having thoughts about depression, having thoughts about in very severe cases suicide, being a little open about it and try to understand a little better. Okay, not to get scared of, okay, what is this? This is what is he talking, and don't talk to me like that, because a lot of times what we have found that people talk about it after getting over a lot of internal resistance, that they don't want to talk about it, but they come and then they find the courage to talk to someone. And if it is met with some resistance, let's say from a teacher, hey, you don't talk to me, or you talk to someone else, they stop talking to other people. So that is something that is definitely useful. Second thing is asking about if the situation is very difficult, or this person is actually very distressed, trying to find out what are the other channels of help or support can we activate for this particular person. It may be about a particular exam situation, it may be about something happening at personal level or at home. So how we can support this person? Are there any friends that this person can talk to? Are there any counselors that this person can talk to get through this situation that can be done? Now, especially for, let's say, depression and suicide, there are a lot of small programs which are available online also, which is called as gatekeeper training. So teachers and family and friends can be the most effective gatekeepers. Now, what do we mean by gatekeepers? Is the people who can identify certain distressing mental health syndromes or situations early, and then can escalate or can route into a particular appropriate level. It may be a counselor, it may be a psychologist, it may be a psychiatrist. So how these symptoms can be identified early, how not being judgmental and giving a supporting hand to them is very important in this situation. So that is something that we can gradually start accepting, not looking at it as, let's say, an additional burden or a load, because that may happen. I mean, it's absolutely, it happens with a lot of people, but being open to helping and understanding that this is a person's crying for help rather than anything else. So how we can help this person is something that we may have to look at these.
Like other diseases, example, cold, etc. Our body automatically take care of. Hello, sir. Am I audible?
Yes.
Sir, like other disorders, general disorders like cold, etc., fever or something, our body automatically treats itself and we get ready. For 1 or 2 days, if we take rest or something. Is there any mental illness is also similar to that, or it is something different?
Very, very good question. We do give these kind of examples to a lot of our patients, that you can actually think of mental illnesses. For example, let's say a patient of depression or a severely depressed patient. I would not say that this is like cough or cold. Okay, but I would say that mental illnesses can be very much similar to, let's say, a prolonged chronic illness like diabetes or blood pressure, right? And thus we need to understand, and that kind of reduces stigma. Why we don't give this particular cough and cold example is that cough and cold may be looked at maybe like a symptom of an illness. Cough and cold may not be the, for example, if a person has TB and this person may present with fever. So the illness may not be fever, illness is TB. Similarly, if a person is talking about some distress, similarly if a patient is talking about dying, talking about quitting, giving up everything, that needs to be looked at as a symptom of something that is underlying. And that is what, so the chronic illnesses can be a more better or more appropriate kind of a model to understand illnesses. Whenever we also talk about mental illnesses, especially a person coming out of on a road to recovery, a lot of people, once they get slightly better, they start expecting a similar kind of a performance like they were doing just before having that illness. A lot of times, an immediate symptomatic recovery may happen, but functional recovery may take some time. And in those cases, then another example would be like, let's say, a person who is a sprinter, who goes for long, very fast races, somehow has a fracture. The fracture may be cured, but that does not mean that on the next day, once the bone is healed, he can again sprint at the same pace. It would need again same kind of practice, going back to the drawing board, starting with new strategies. What is the current level of working? What is the current level of functioning? So these are the more appropriate examples to understand what happens and how psychological disorders work. So more like a non-communicable, a chronic illness rather than something that comes and goes. Of course, those kind of illnesses are also there, but typically what we call as common mental disorders or even severe mental disorders, that kind of model is more appropriate to understand.
Thank you, sir. Because of that, we are always under tension. Whether these tensions, daily tensions, we are not getting proper sleep, we are not coming to the work, we are not doing work properly. These are all some symptoms of mind or what?
So these are definitely symptoms, but whether they would deserve a diagnosis is something that maybe I'll take 1 or 2 minutes to tell about how do we diagnose. Whether I have certain stress or I'm not able to sleep or I'm getting some thoughts, whether just getting it, whether will it be called as a diagnosis or not, right? So what we generally look at is not necessarily, of course we need to have certain symptoms to make a diagnosis. Just having an isolated symptom, just one symptom, a lot of times does not give a diagnosis. So we have to have multiple symptoms of a particular disorder. That symptoms should be present for a particular amount of time also, right? And then we'll be able to tell, okay, this person is sad for a very long time, more than a few weeks. Along with there are certain other symptoms, and thus this person has depression, right? Third thing that we look at is how much is the distress caused by the symptoms. That the symptom is not there for a very long time, it's very short time, but it is causing a lot of distress. I'm not able to function at all, I'm not able to do anything, it is making me very, very anxious, very, very sad. In those cases also we can make a diagnosis. That if the distress is very far significant, then we can make the diagnosis, then that becomes disorder. If the symptoms are causing a lot of dysfunction, you mentioned that a person has a certain potential, but he is not able to achieve his potential. His regular day-to-day functioning, it may be occupational functioning, functioning as a teacher, functioning as a husband, functioning as a father, functioning as a son. If those functioning in various domains of your life, if they start getting affected because of the symptoms, then we may have to think whether, okay, am I going through a period of any problems, right? Again, psychiatric illnesses again, because of their inherent nature, a same symptom can be present in various illnesses also. So that is something also that we need to understand, that if a person is feeling sad, it may be present in various disorders and not just depression. So we need to look at what are the various symptoms this person has, and then what is he or she going through. A lot of now, more and more we are talking about stress-induced disorders, what we call it. That this may be because of the stress in this particular person's life that he is having this symptom. Once the stress is removed, the symptoms will go away. So we are giving a lot of classificatory systems that we use. We are also giving a lot of importance to these stress-induced disorders. So yes, you have to look at all these things and then think of whether we are having any illness or not. What AI or chatbots or these tools will be able to help is to tell you, okay, this is the symptom. Do you have the symptom? Yes. How often does it happen? Yes. How many days does it? So that is something that questionnaire kind of approach can be used. But whether it will, and thus it can be used as a screening that, I'm scoring very high on this. Let me go and have a word with a mental health professional. So that maybe AI can be useful in that, and that is something that those kind of questionnaires are even available for general public also. So they can also go through that, see, okay, these many things are there, let me go and talk to our specialist.
Thank you, sir. Sir, you are telling about someone observed about, he may be having some issue. Sir, we don't have anyone. I cannot be observed by anyone. And I don't want anyone to be observed. See, I want to observe for myself, and I should know whether what is the problem to me.
Correct.
For that, is there any clue or any?
Yeah, as I mentioned, for example, if you don't want to talk about these symptoms to other people, if you don't want to, then there are some questionnaires which are available, which are actually patient faced. They're called patient facing, okay, or client facing. Client facing meaning you don't have to have another interpreter for that question. Another person did not read the question, ask you the question. If you are giving an answer, interpret that answer and fill in the score. There are a lot of such tools available which talk about anxiety related scores, depression related scores, which are the most common disorders across all populations. So these kind of things are available.
Thank you very much.
Thank you.
On behalf of Amrita Institute of Engineering and Management Sciences and all the participants, I would like to express my heartfelt gratitude to Dr. Deepak S. Gadigaonkar, Assistant Professor in the Department of Psychiatry at MIMS, Bengaluru, for delivering such an enlightening session on AI in mental health. Sir, your talk opened our eyes how artificial intelligence is truly transforming mental health care from early diagnosis and risk prediction to personalized treatment and intelligent clinical support systems. You explain complex ideas with such clarity and real-world relevance. Thank you, sir, for sharing your valuable knowledge, time, and vision with us today. Your guidance will help us all to understand the future of healthcare better. Now, I request Dr. Pratibha Devi Tapashetty, Professor, Department of Electronic and Communication, and Dr. Nagananda, conveyor of this FDP, to hand over a gift as a token of love, respect, and as a mark of our gratitude. Thank you once again, sir. Thank you once again, sir. Now I request all the participants to gather in the auditorium at 2 o'clock for the next session.